Najpierw kamera to jeszcze. Good morning, everyone. Welcome to the second day of our annual conference. Welcome also to the online participants. Today we will have panels that will be only online. So we are starting with natural and human-induced hazards. And this panel will be till 12:15. We will have one coffee break. At 10:15, there will be 10 presentations. And just one reminder that all presenters will receive certificates online by emails. So we are now ready to commence this panel. The floor is yours.
Good morning, esteemed colleagues, dear guests, panelists. It's my honor to welcome you to this session of our annual conference on crisis management and disaster response. In this panel, we will discuss about critical topics that are at the forefront of crisis management and disaster response. We will explore natural and human-induced hazards in order to understand the dynamics and the impacts of these hazards, and it's crucial for developing effective mitigation and response strategies. Before we begin, I would like to remind everyone of the importance of active participation, and your questions and contributions are vital in enriching our dialogue and advance to our collective understanding. In order to present the first participant, I will give the floor to Professor Trifon.
Good morning from my side too. The early morning session, we are starting with earthquakes. We know that they are one of the most deadly disasters. So the first presentation will be delivered by Dr. Maria Popova, who is geophysicist, seismologist at the National Institute of Geophysics, Geodesy and Geography of the Bulgarian Academy of Sciences. And her talk will be dedicated to two moderate earthquakes and the observed defects in the other geophysical data. So, Maria, we are waiting for you. The floor is yours.
Earthquake in Asenograd area, Bulgaria. Earthquake with epicenter in the vicinity of Plovdiv, Asenograd, had a magnitude 4.8, and the depth of the hypocenter was 10 kilometers. The quake was felt throughout Bulgaria, and there are also reports that this saw also felt in neighboring Greece. The intensity in the epicenter zone was estimated as 6.5, and in the rest of the country is varied in the range of 3 to 4.5. It was followed by a series of 18 aftershocks after that lasted until June 10th. Two of the aftershocks had magnitudes of 3.2 and 3.6. On this picture, we present seismograms of the major shocks recorded at the Plovdiv seismic station. The earthquakes data are recorded by the Bulgarian National Operative Telemetric System for Seismological Information and contains previously processed information about the parameters of each seismic event for the period June 7 to 10. The time series of geomagnetic field variation along X, Y, and X-axis were recorded at the Geomagnetic Observatory Ponegirište with a resolution of 1 second. The measuring instrument is an induced magnetometer. The seismic station with the international code PGP is also located at the Geomagnetic Observatory. The data sets about the solar wind parameters, the interplanetary magnetic fields, and the geomagnetic activity were downloaded from OmniWeb. Based on the macroseismic cells of MHK64 model, the map seismic intensity was constructed. Variation of the geophysical parameters as a function of the time are presented. The dynamics for the X and Y components of geomagnetic field variation are obtained via the Morley wavelet transform. On figure 1, the epicenter of the main shocks and aftershocks for the period June 7 to 10 are presented on the map. The main fault structures are depicted as well. The northernmost and southernmost lines of the fault structure are roughly in the west, northwest, and east, southwest direction. Most earthquakes epicenters are located between these two fault lines and are arranged along a single line that is located across the two fault lines. The development of fault structures in the area is not very well studied, and the arrangement of the epicenter of the geographic map in one line gives indications that there are probably active geological processes in the area that gives rise to a new fault structures or remodel existing ones. A macroseismic assessment was performed of the MHK64 scales of the impact of the earthquakes on the environmental based on data reported by population in the settlement located in the epicentral zone and the National Civil Protection Service, as well as from settlement throughout the country. A maximum intensity of 6.5 was determined in the village of Krumovo, Kotunica, and Karajovo, each of which is located about 5 kilometers away from the epicenter. Effects such as swaying, shifting of heavier objects, destroyed chimneys, tearing of large pieces of plaster, and large cracks in the building stocks were described, with the school in the village of Krumovo having large cracks in the wall and broken windows. Disturbing behavior in farm animals and pets has been observed. The earthquakes was accompanied by a rumbling that was heard in addition to the epicentral area and in other settlements such as in the cities of Plovdiv, Asenograd, Chirpan, and Stara Zagora. The maximal intensity varies in the range of 4 to 5.5. In other parts of the cities, the intensity was determined to be smaller than 3.5. Panagurište is in the northwest direction for the epicenter of the above-mentioned seismic events, about 17 kilometers. Figure 3, the geomagnetic field's variation in the ultra-low frequency range recorded in the observatory along the X blue line, Y red line, and Z yellow line direction for the period June 7 to 9. The main shocks and the four most powerful aftershocks are marked with black arrows. Only along the Y component, unusual disturbances were recorded. Almost immediately after the main shocks, the values of the I components are going to rise, and at about 14:30 UT on June 7. The sharp peaks of variation appear the last until June 10, when the aftershocks activity stopped. There are three main fundamental reasons for the appearance of sharp peaks along the X and I components of geomagnetic fields variation. The first one is linked with natural phenomena, including the solar-Earth interaction and processes arising for the Earth's lithosphere. The second one is related to processing originating from anthropogenic activity. The mechanical impact over the measuring instrument, however, these reasons may be ruled out since the magnetometer was installed according all the rules of observatory measurement. It is a measuring instrument with higher stability sensor, and in the construction they are on AGE suspend sensor with which in other types of magnetometers reflected the swing during earthquakes. If there was a mechanical swing, it would also be reflected on the other two components, X and Z, but not such reaction. Let's shed lights on this issue as we analyze the previous two possibilities in more detail. 5. Depict the dynamic spectrum for the X and I components obtained by Morlet-Whiteley analyzed for the period June 7 to 9. The dynamic spectrum for the I components shows more powerful disturbances than those for the X component. This result is unusual since it is expected that the perturbations that originated in the Earth's magnetosphere manifest better in the X component than the I one. Our experience has shown that for disturbances or geomagnetic variation related to another anthropogenic activity, the disturbances are not stable in time and their spectrum power is much weaker than that of natural origin. In the present case, a persistent pattern of disturbances was observed, which lasted for about 3 days. Such components of the interplanetary magnetic fields, the solar wind plasma speed, the flow pressure, and the Kp and DST indices for the period June 5 to 10 were presented in figure 6. This time windows is chosen to cover June 5 as well. Since the ground processes associated with changes in solar wind parameters reach the Earth's surface with daily on the order of hour, the values of the Kp and the DST indices don't indicate any disturbances, and the analyzed period was quiet for the geomagnetic point of view. The speed of the solar wind and its dynamic pressure are also not characterized by significant changes in values. They are not stepwise changes in the variation of the dynamic pressure that lead to variation in the magnetic field's values, which the usual more pronounced along the X direction. The variation of the physical parameters depicted the figure 6 cannot provide a mindful explanation for perturbation in the magnetic variation that are observed only in the east-west direction. Global disturbances in the magnetic field appear almost simultaneously and are recorded at different observatory and, of course, different latitudes. They are characterized by local and regional spectral features. Similar variations were not found in the available records of the other observatories closest to Ponagurishte. This points our attention to a cause that is most likely relate to local or regional perturbations that are not strong enough to penetrate over large enough distance to be recorded mind that the main fault structure in the area are located in the northwest-southwest direction for Ponegirište, occupy about 70 kilometers away in the same direction. It can be a seismon that geomagnetic disturbances wouldn't be related to post-seismic processing. Since one evident example of this possibility. Disturbances was found in the geomagnetic vector variation in the east-west direction recorded at the Ponegirište Geomagnetic Observatory, which is located about 70 kilometers away from the epicenter. They appear immediately after the earthquake and continue until June 10, 2023, when aftershocks activity ceases. According to the results obtained and the descriptions carried out, it can be said a local or regional character, and the probability that they are related to solar terrestrial interactions or mechanical ones is significant. Even the geographic location of the fault structure which the earthquakes occurred and its subsequent seismic activity, the possibility of post and post-seismic activity influencing the electromagnetic background as part of the environmental cannot be out. Thank you for your attention.
It was a really interesting presentation. I'm not sure how the questions will come to us.
Yeah, we have received the questions through our platform. So for everyone who is online, and if you have some questions, you can address those questions through our website. No, we can receive questions during the session, and also we can receive some questions at the end of the presentations.
Okay. I have one question. Can you hear me? Maria?
Maria, are you still with us?
Yes, can you hear me?
I have two very small questions. You said that the magnetic disturbances were observed immediately after the earthquake happened, but what immediately means? Few seconds or at the same time?
Few seconds? Sorry?
Few seconds or at the same time with the earthquake?
Not at the same time, but immediately after earthquake.
And because if you have 70 kilometers distance, you can expect the seismic wave to arrive in about 10 seconds. Do we have a 10 seconds difference between the two effects or not? Between the geomagnetic disturbances and the time of earthquake occurrence?
Sorry, I can't hear clearly some.
I have asked if there is at least 10 seconds difference between the time of the earthquake and the first peak of the geomagnetic disturbances.
I think no.
The interval is smaller?
More?
Okay.
The
And my second question, I saw you have evaluated the intensity values of the earthquake. Are they the same?
this picture?
Maria?
Yeah.
Okay, can you hear my second questions? Yes or no?
Intensity along the calculated along the x component, or?
Maybe one comment. If you are looking to the YouTube, we will have problems, so please stay only on the WebEx platform. And switch off the YouTube channel.
Maybe here.
It is very important for everybody that the communication needs to go only through the WebEx. Because if you are watching YouTube, there is a time difference between the real conversation and the YouTube streaming.
Yes, I know YouTube switched off.
Okay, so my second question is if you have evaluated the macroseismic intensity near to in the epicentral area, is there any difference observed to the north of the epicenter and south of the epicenter? Is the intensity different looking to the north and to the south? Because Panegyriște Observatory is northwest of the epicenter. Okay, maybe it is better to have a question and answer session after the.
Yes, we will keep this question for the end of the presentations. So thank you, Maria, for your very well prepared presentation. And if we don't have any other questions, we can move to the next presentation.
Good morning.
Good morning.
Do you hear me?
Presentation, yes, we hear you. Perfect. We see you perfect.
Okay.
So, our second presenter is Dr. Anastasia Stoicheva. She is a scientist from the National Institute of Meteorology and Hydrology, and the presentation will be dedicated to some multi-hazard effects with such phenomena. We will hear about the occurrence of high ozone, PM10, high temperature, and desert dust intrusion. So you are welcome.
Do you see my presentation?
Yes.
Okay. Good morning to everyone. My name is Anastasia. I'm from National Institute of Meteorology and Hydrology, and glad to share with you our team work concerning multi-hazard event, a very special and interesting interconnected occurrence of high ozone, PM10, high temperature, and desert dust intrusion. 2 words about our team. It is leading by Professor Emilia Georgieva, and I have to mention my colleague, expert physicist Kristina Kirova. We are from different departments in National Institute of Meteorology and Hydrology, but by combining our expertise, received beneficial results. To move to next slide. Okay, let's say a few words about hazard events that we considered in our investigations. Each of these events itself is interesting and needs to be monitored, but the events combination, their analysis and prediction become a challenge. Maybe you know heat wave is a prolonged period of unusually hot and dry weather with duration at least 3 days. Have shown term effects on the different type of diseases, human diseases, electricity demand, and etc. High particular matter concentration is an important factor for air quality in urban areas. That's why we look at the high concentration of aerosols. Intrusion of desert dust is one reason for increasing the PM concentrations. Long-range transport of mineral particles from desert regions impact on human health, aviation, solar energy, agriculture, air quality, etc. And finally, let's mention ground level of ozone, which is strong oxidant and have negative impact on human health and vegetation. All these events have both short-term and long-term impact on human health, and most importantly, they have synergetic impact. That's why we have to consider them as a multi-hazard event. Sorry, I can't move to the next slide. I don't know why. Okay. When we started to study this multi-hazard event, the primary goal of our study is to raise awareness that multi-hazard events are occurring in Bulgaria. In addition, we want to share products and services allowing the forecast of such events as a necessary step towards short-term measures by authorities. And last but not least, as a scientific and operational institute, to contribute to methods for studies on such events, allowing long-term impact assessment and relation to climate change. In the following, we discuss a summer case, the period 24-27 of July 2023. On this slide, we can see the main steps of methodology that we use for identification and analysis of the hazards. We have uses of a combined analysis of data and information from various sources. In general, these sources are related to prognostic modeling results and to different data from observations as well. Useful numerical models products are synoptic charts from ECMWF, from NSTEP and reanalysis or other numerical models. Results from air quality models provided by Copernicus service on atmospheric monitoring, and back trajectory analysis that might indicate the origin of the air masses. Observations data refer to in situ meteorological and air quality monitoring, satellite images, of course, and remote sensing data for aerosols. In the next slide, we show the main results from the analysis of the event during period 24-27 of July. The period is marked by transport of warm air masses from northern Africa that were also loaded with dust aerosols. On this slide, you can see the combination of satellite picture and synoptic charts. Here, with this pinkish color over Africa, it is the Saharan dust lifted up in the atmosphere. The concentration is very high, and this dust this dust cloud could travel to long distance and can influence the air quality over the Balkans, over Bulgaria as well. There are some specific analyses in methodology at geopotential height of 500 hectopascal. The 200 hectopascal chart is also very important. They are not shown in this presentation. But it is very important to have 24/7 process monitoring to catch and follow all specific points in this analysis. From desert sandstorm that you could detect from the satellite pictures to long distance transport because of suitable meteorological conditions. On the next slide, in this period, in July 2023, sharp increase was noticed in the temperature all over the country, maximum observed at surface level up to 43 degrees Celsius. Model results indicate that in altitude at about 3,000 meters, the anomaly of the temperatures with respect to climate is about +6 degrees Celsius over Bulgaria. You can see this on picture in the corner on the left. On the next slide, the high temperatures were associated also with the transport of dust particles, as indicated by CAMS regional model. The models indicate mean daily dust concentrations on 25 and 26, these two maps here, of July, of about 15-20 micrograms per cubic meters. And model also clearly points to the origin of the air masses during these days, as shown on the next slide. The air masses at different high levels are associated with transport from desert region in Northern Africa, as we can see from back trajectories. The dust transport impacted significantly the PM concentrations. And this is noticed both in modeling results from the observations, as shown on the next 3 slides. On the next slide, we can see some important modeling results. The CAMS modeling products show the spatial distribution of PM10 concentration as the maps for daily mean value on the upper row in this slide, or as chemical speciations graph below, showing dust as main contributor to PM10 in Sofia. You can see high concentration on surface level, especially on 25 and 26 of July. On the next slide, the modeling results for high aerosol concentrations are in line with data by observations from data at the air quality stations in Bulgaria and from satellite products and Aeronet data on the next slide. Both sources give information for the aerosol load in the entire atmospheric column, whole atmosphere, through aerosol absorbing index or aerosol optical depth. And next slide, some words of surface ozone concentrations. Results by CAMS regional model showed as map indicate higher values on 26 and 27 of July along the Black Sea coast. You can see on the map here. Maximum hourly values of about 120 micrograms per cubic meters. This is confirmed also by observations as shown on the next slide. The bars here, the bars show the daily variation of daily maximum ozone concentrations during the 4 days period. The increase of the third days is evident at the Black Sea stations. You can see 2 stations, three stations on the Black Sea, Varna, Nesever, and Burgas. Here is the column for the third day. Just to mention that in summer, many tourists are outside, you know, our nice summer Black Sea during summer, and people are on the beaches. And on the next slide, here conclusions are coming. We have seen that in Bulgaria, event, weather or air quality related, may occur simultaneously. Of course, these events may be forecasted by combined analysis of a set of products and services already available at the National Institute of Meteorology and Hydrology. The impact of these events should be investigated in multidisciplinary studies. At the end of this slide, I do not read all these conclusions, but I would like to stress in this red box, there are the web pages with available products. The last web page is a result of experts and scientists' work on a project with Copernicus program, still ongoing in National Institute of Meteorology and Hydrology. And next slide, please. This work also is a part of 2 projects of scientific plan of our institute as well. You can see here. Thank you for your attention.
Thank you, Dr. Stocheva. It was very interesting presentation. I remember this time last year when we have the desert sun. I have one maybe stupid question. I saw that the dust is coming from west and not from south. Why so?
Yeah, thank you for this question. It is not stupid. Usually the dust comes from Sahara Desert, but in some cases dust travel southly of Bulgaria and comes to Bulgaria from southeast. It depends of meteorological situation. And there are another cases, they are much more or less than those from Africa Desert, dust from Africa Desert, when dust is dust origins from Alarcum Desert. This is east of Bulgaria, over near to near the south part of east part of Black Sea, and by the southeast flow, it is come to Bulgaria.
Okay, thank you.
Thank you for your presentation. I also have a question. When you observe that a high concentration of PM10 will occur soon, do you have any official channels in order to inform the population? I mean, like media, maybe BG Alert or some other channels?
Yes, through the media we try to stress for this event, but actually we do not measure this. Our municipalities has has expertise to measure these concentrations. In National Institute, we also detect, we have expertise on which is the situation from synoptic point of view, which could bring over Bulgaria this PM10 and respectively dust. But yes, through the special bulletins to Ministry of Environment, we send special information every day for synoptic situation, which brings to Bulgaria dust. And if we have possibilities, we discuss this in some media.
Thank you very much.
I think we don't have more
Yes,
questions.
we don't have any other questions. Maybe in the public there is someone who wants to add a question. If not, we can proceed for the next presentation.
Thank you.
Thank you.
The next presentation will be delivered by Professor Nikolai Milev. Are you online with us?
Yes, hello, can you hear me?
Oh, yes.
Okay, shall I share my screen?
Yes.
In the meantime, I will say that Professor Milev is a lecturer and scientist from the University of Architecture, Civil Engineering and Geodesy in Sofia. He is specialist in geotechnical engineering, especially in soil dynamics and the local site effects. We will hear a presentation which is dedicated to the local soil conditions on damages in the Kahramanmaraş during the strong earthquakes in Turkey last year. We can see the presentation, so you are welcome to start.
So thank you very much for the introduction. My name is Nikolai Milev. Please excuse me for not having the camera switched on. It's because of the computer which I'm using. So anyway, the topic of the presentation is the influence of local soil conditions on damages in the Kahramanmaraş earthquake during the 2023 Turkey-Syria earthquake. So this study is a collaboration between Japanese side, Bulgarian side, Turkish side, and then a few engineers from Mexico as well. So it is kind of a joint effort. Okay, so this is the outline of the presentation. We will start with an introduction, then a few words about the goals and the team and the investigations which are carried out on site, and then the main focus would be the local site, the geological effects in the response in Kahramanmaraş. So, as you all know, unfortunately, a tragic event happened in Turkey and Syria last year on February 6th. So we observed two major shocks. One of them during the night, 4 a.m. in Kahramanmaraş, having the magnitude of 7.7. Then 9 hours later, another strong shake was registered in Elbistan. Multiple aftershocks after that, over 11,000 aftershocks actually. So an important conclusion out of the records is that peak ground accelerations up to 1.2 G, 1.2 times gravity, have been registered, which is quite significant. So it was a slip fault, which, as many of us know, usually leads to significant damages, unfortunately. So the consequences are quite brutal. I'm sad to say that. So more than 50,000 fatalities, more than 15 million people affected, and more than 35 buildings completely, 35 million buildings completely destroyed. So it was a huge shock for Turkey and Syria. So a few surveys have been carried out on site, first of which was just after the earthquake in the end of March 2023. So it was organized by the Japanese Architectural Institute. So engineers from mostly the structural engineering field were there, coming from Japan. And there were two professors, engineers in the geotechnical field. So that was the team I joined back then. So we had a team coming from Bulgaria, which included two Mexican engineers who came to Bulgaria, and together we traveled to Turkey in order to carry out some measurements and some investigations on site. So starting from March, then May, and then October, 3 site investigations were performed. This is how the route looks like. So in blue, you can see the fault. In green, you can see the epicenter of the two major shocks in Kahramanmaraş and in Elbistan. So during our first visit in March and early April, we tried to cover most of the affected areas, and we tried to investigate zones in which geotechnical failures are observed, as we had another team dealing with the structural part. So in any case, there were some distinguishing failures from geotechnical point of view, especially in Iskenderun and in Gölbaşı, where multiple liquefaction cases were discovered. But that's not the topic of today's presentation. So the topic is Kahramanmaraş, which you can see is more or less in between the two epicenters from the two major shocks. So, by the way, another site visit is planned for next week as well, on site, this time in Gölbaşı. So, since we try to cover multiple points, multiple places, right after the earthquake, we needed some methods, we needed some measurements which could be performed relatively fast. So in this case, we went for the dynamic penetration tests on the left. So it's a classic geotechnical method in order to investigate soil conditions. Then in the middle, we performed the multi-channel analysis of surface waves, or the MASW, in order to measure the shear wave velocity up to 30 meters. And on the right, you can see the Nakamura method, or also called the HV method, in order to measure the predominant frequency of the soil deposit. So these were the 3 types of measurements which we performed in most of the places that we visited. So speaking of Kahramanmaraş, you can see a geological map of the city, most of which consists of quaternary soils, which have the age of less than 2.6 million, so they're less than 2.6 million years old. So the important observation in Kahramanmaraş was that in the yellow zone, which you can see on the map over here, some major damages were observed, while outside the yellow spot, much less damages were observed. So it was kind of a very interesting phenomena to observe on site. So as you can see on the bottom right, Kahramanmaraş has some slopes around the city as well. So zooming in, you can see the gray area in the yellow rectangle. Zooming even more in, you can see that we have a zone in the city which has lots of damages compared with the buildings which are around that area. So in any case, most of the structures have been designed and constructed in a similar manner, which would mean that we would have to think of another reason why exactly in that area so many buildings collapsed. We took a map which was prepared by some Turkish researchers in 2020. So they prepared a map of the shear wave velocity up to 30 meters, the so-called VS30, all over Kahramanmaraş. And we did our own measurements as well. So we selected two spots, one of which was in the zone with multiple damages, so the so-called red spot in the presented paper, and then on the other hand we had another spot, the green spot, which was next to the affected area, and in between those spots which we took measurements in, there was a station 4620 which recorded the strong motion of the earthquake. So this was the only strong motion record in that area. So what we measured in those two spots was, as mentioned previously, the VS30, or the average shear wave velocity up to 30 meters, as well as the predominant period in those places as well. So what we can see is that speaking of only shear wave velocity, VS30, we can see that the difference is not so significant. So we have the 405 meters per second in the area with multiple damages, and we have the 547 meters per second in the area with less damages, which maybe in this case would mean that the VS30 is not sufficient in order to to capture the effect of the local site conditions. And unfortunately, this is the only parameter which we adopt in order to classify soil when we design everyday structures. So measuring the predominant period of the soil deposit in those two places gave us the information that the distance from the terrain, from the surface, to a relatively stiff layer or rock is different in those two places, which maybe in this case played a significant role. So in any case, in the following two slides, you will see the actual measurements in those two places. So starting with the so-called red spot with multiple damages, using a rule of the thumb formula in order to define the distance from the terrain to the stiff layer, we need the predominant period, we need the VS30, so we assume that the distance is 35 meters. And in order to classify soil medium according to Eurocode 8, the seismic standard which we use for structural design in Europe, that area should be classified as type B. Moving on to the other place with much less damages. So once again, speaking of VS30 and Eurocode 8, soil should be classified as soil B. So in other words, if we stick to everyday engineering practice, we would definitely miss the effect of local site effect if we simplify things too much. So in this case, measuring the predominant period as well, we assume that relatively stiff layer is closer to the surface. Another interesting observation was the record in station 4620, which, as I mentioned, is in between the two spots which we took the measurements in. So, as also mentioned a bit earlier, Kahramanmaraş is kind of more or less in between the two epicenters. However, the impact of the first shock compared to the second shock, I mean, the difference between those two impacts was quite significant, which could be seen on the right with the response spectra. So red, first shock, blue, second shock. As you can see, the response is significantly different, and of course, the effect of the earthquake on structures was significantly different as well, which would mean that magnitude in some cases, or in many cases, is not an indication what to expect and what damages to expect. So it really depends in some situations on local site conditions, on soil layers which are near the superstructure. So the reason for so many damages might be the so-called double resonance, which would mean that the predominant period of the earthquake motion matches the predominant period of the soil deposit, which matches the predominant period of the superstructure. So in such case, I would say very significant acceleration is observed, and very significant damages are observed during earthquakes. And by the way, this is the case with the 1985 Mexico City earthquake. So in Mexico City, there was a specific zone in the city center of Mexico City, which was at a distance of 380 kilometers, so quite far from the epicenter. So in exactly that area, there were lots of damages similar to Kahramanmaraş. So researchers and engineers later on concluded that the cause for such response was the double resonance effect, and it is very well described by Professor Gazetas in one of his video lectures, which is available online, so anyone can have a look if they're interested in it. So in order to conclude, I think we covered most of the important points, more or less, but probably the most important one would be that PS30 might not be the sufficient criteria in order to classify soil medium in terms of seismic response. So, and final conclusion, in order to have a good response, we always need good foundations and good superstructure. So if one of them doesn't work well, then always the effect is very bad, and this is what we observed in Turkey and Syria, sadly, of course, after the earthquake from last year. And I would like to thank you for your attention.
Thank you very much. It was a very interesting and informative presentation. There are a lot of investigation of the consequences and observations after the Kahramanmaraş, after the strong earthquakes in Turkey. I have one short question. Do you know when do you have information when the most of the buildings has collapsed, after the first earthquake or after the second, or when? At the same time or not?
Yeah, so thank you for your question. Speaking of the two major cities, Kahramanmaraş and Antakya, so it was interesting to observe that Kahramanmaraş was significantly affected by the first shock, and Antakya was not. Of course, Antakya was also affected, but not that much, I mean. And after the second shock, Antakya was severely affected, and unfortunately in Antakya there are the most damages. So it was different in different places. So once again, it might lead to the, let's say, to the major focus of this presentation, that local site effects are quite important.
Yes, they are indeed.
Thank you. I also have a question. Is there any connection between the Earth surface, I mean hills, lakes, river valleys, and the risk of building collapse? According to some urban legends, maybe based on this information, which says that some areas are more dangerous than others.
Okay, so to be honest, I'm not a seismologist myself, but in any case, local site effects are how to say, the last part of the, let's say, travel distance of the seismic waves is what really matters. Of course, there are many, how to say, factors which could affect the reach of those waves up until the medium, which is right below the substructure. But how to say, the parameters and the properties of those soil layers is what matters in the end, in the final, let's say, distribution of the waves along the medium to the substructure.
Okay, thank you. Are there any questions from the room? If not, we can go to the next presentation. Thank you very much. Our next presentation is dedicated to the investigations in some of the show caves in Bulgaria. I would like to invite Professor Nuzharov, if he is there. Yes.
Yes. Do you hear me?
Yes, we can hear you.
Yes, I'm also using a desktop computer, so you will not see me, just hear me.
Okay.
Is this what you are sharing, or it's me? Because I see on the screen.
We are sharing.
We are sharing. Are you okay with this?
Yes, but I cannot move the slides, or maybe I will share my phone.
You are welcome to share your screen now.
Okay, let me try.
In the meantime, I will introduce Professor Nuzharov. He is a scientist in the Institute of Climatology, Atmosphere and Water, the Bulgarian Academy of Sciences, Climate, Atmosphere and Water Research. Is that your screen? Yes?
Yes, do you see it now? Because
yes.
I don't see you, but I see only my screen.
We also see your screen, so...
Yes, so now it's okay. Okay, now I'll present our study, which is Global Changes and Tourism in Show Caves in Bulgaria, Hazards and the Relationships. This study was done together with my colleagues Petar Stefanov and Tiljana Stefanova from the National Institute of Geophysics, Geodesy and Geography, and also together with Karel Turek, who works in Nuclear Physics Institute, Czech Academy of Sciences.
You can switch to full screen mode.
I am on the full screen mode. Do you see it now?
We see the presentation, but it's not a full screen.
It is full screen on my computer. I don't know. Do you see it now?
No, maybe you have shared the presentation, but not the screen. If you share the screen, it will be better.
You
The full
can stop
screen.
sharing and after that to start sharing again.
Stop sharing. You can stop sharing now and then start sharing again the full screen, the entire screen.
Okay, let me try again. So now, okay, I stop it. Now I'm.
And now share only the screen.
The entire screen.
Yeah.
Okay, let me try now. So, do you see anything?
Yes.
It's perfect now.
Yeah.
Now, okay.
Yes.
Okay, now, okay, I'll move to the next slide. So these are the objects of our study. These are 13 show caves in Bulgaria. You can see them. There are Magura, Veneца, Леденика, Саева Дупка, Бачо Киро, Орлова Чука, Бисерна, Снежанка, Ягодинска, Дяволско гърло, and Уховица. These are electrified caves, and also Lepenica and Devetashka cave, which are non-electrified caves in Bulgaria. So what we are doing integrated monitoring of karst systems, which is called MIX, which includes also SperoMix in two ways. During expedition trips, measurements in the caves, and also with instrumental measurements with automatic stations in the cave. What we are monitoring, some meteorological elements, like temperature, humidity, and also some gases in the caves, mainly concentration of CO2. There are also radiological monitoring, concentration activity of radon, and total radioactivity, gamma background. And also there are some tectonic measurements and seismic activity, three-dimensional displacements of the walls of some caves. On the left side, you can see the work in progress in the caves on these pictures. So some results. First, there's some connection between climatic change and speleoclimate in the caves. You can see here, first, this is the course of CO2 concentration and radon concentration in Săeva Dupcă cave. You can see here on this graph that the maximum concentration in this cave is during summer, and the minimum is in winter. This is connected with the ventilation regime of this cave atmosphere, and this ventilation regime is also connected with the outside temperature. Roughly, when the outside temperature is below the inside temperature, there is income of cold air in the cave, and ventilation regime starts, and the concentration of different gases lowers. And the opposite, so when the temperature, outside temperature, is higher than the inside air temperature, there is a period of accumulation of gases, and this is the period with no ventilation in this cave. Of course, this regime depends on the morphology of different caves. This is just the case of Săeva Dupcă. You can see, maybe, okay, I'll go to some other effects. We can have some natural disasters which are increasing as a result of climate change, and they affect the tourist caves. You can see here on the left upper picture, this is some flooding of the entrance of Ledenik cave, which happened after heavy rain on the 14th of September 2014, and 20 tourists were stranded in the cave. Also on the center and right upper side pictures of this slide, you can see that a collapse of this attraction model, which is in front of this cave, Ledenik cave, due to the accumulation of snow on its top. You can see the results. Fortunately, there was no casualties during this event, and on the bottom you can see some results from the flooding in the Dyavolsko Grlo cave, which happened on the 12th December of 2021. There was a 100-meter high vortex in this cave, and you can see the results. There are a lot of debris and alluvial clay deposited on in the cave. This cave, this is also a tourist cave, show cave. There are some anthropogenic hazards in the caves. You can see here on the left side the so-called wampen or wamp flora, which let's say grow on the walls of the cave due to the heat and light from the lamps which are installed in the cave. And also on the right side, you can see this is the case of, again, in Seva Dubka cave. You can see some infrastructure which is right above the cave. This is the parking lot and the toilet, and some of the water which is, let's say, goes from the toilet to the dripping water of in the cave. So there's some pollution of the water in the cave due to this infrastructure, and also the tourist which enters the cave, they rise the temperature of the cave because of their body temperature, and also they rise the concentration of CO2 because of their breathing. Okay, this is the some results. Health hazards due to gas composition. You can see here the CO2 concentration in the tourist caves. These are along the routes of the tourists in the cave. These are the cases of Seva Dubka cave and Biserna cave. The limit which is accepted in Czech Republic, not in Bulgaria, is roughly 10,000 ppm for CO2 concentration. So above this limit, the CO2 concentration becomes hazardous to the people in the cave. And you can see that in Seva Dubka and in Biserna, deep inside the cave, this concentration is above this limit. Of course, I have to say this is concentration in the accumulation period. It means during summer. So this is the annual regime of radon concentration, and as you can see, most of the caves have the regime with the minimum in winter and maximum in summer, as I told previously for the Seva Dubka. This is also valid for Veneța, Ledenica, Biserna and Uhovica, and this is not valid for Baču Chiru cave. This is due to the morphology of every cave, so it could be a different regime in every cave based on its morphology. So here you can see a calculation of effective dose of radon radiation. This is important. I will not go into details. You can see here the formula, but this is important for the effective dose for the personnel or tour guides which work in these caves. Here we accept the effective dose limit of 6 millisieverts during 1 year, which is 2,000 working hours. This limit is also from the Czech colleagues, from the regulations in Czech Republic. We don't have regulation here in Bulgaria. And on this slide, you can see the calculations of individual effective doses in some of the cases where we have measurements and we have information of the stay of the tour guides in the cave during the whole year. And you can see here that in Venezia, with the red numbers show effective doses which are above this limit of 6 millisieverts, and you can see that in Venezia it's well above this limit, and also in Serva-Dubka, in conservative approach, it is also above this limit. So the other 3 caves are not that dangerous. So this is there are some concerns about the health of the tour guides in these caves because of these effective doses. Of course, they do not apply to the tourists because they stay in the cave much less time compared to the tour guides. So you can see here the potentially most dangerous tourist caves in terms of concentration of CO2 in the cave. In cave air, the most dangerous are Ledenika, Serva-Dubka, Biserna and Snežanka, and in terms of concentration of radon, the most dangerous are Venezia, Ledenika, Serva-Dubka, Baču-Kiru, Orlova Čuka, Biserna, Snežanka, Lepenica, which is quite a big number of caves. There are also some hazards of rock mass collapses. This example is Devetashka cave, which is a very huge cave. These are pictures of Great Hall. Maximum height of the walls is 48 meters, and there are 7 openings, windows in the arch of these caves, and through these windows, there is a possibility of falling of some big rocks down to the floor. And what is important here is that the tourist can go free there. There is no security measures. There are no tour guides in these caves who can warn the tourists. So there is a high risk of some casualties because of falling of big rocks from this ceiling. There are also risks of falling of rocks because of high tectonic seismic activities. This is the case of Baču-Kiru cave. On the right upper picture, you can see there are some faults passing through this cave. Also on the right bottom picture, you can see the faults in the cave actually. And you can see here we tracked some earthquakes, 6 earthquakes in the period between 2012 and 2016. These are displacement of the cave walls during these earthquakes, and you can see that there are some displacements in both horizontal and vertical directions. Let me, in conclusion, potentially most dangerous tourist caves in terms of concentrations of CO2 and radon, I already told them. There are Venezia, Ledenika, Serva-Dubka, Biserna, Snežanka, Lepenica. In terms of risk of rock falls, this is Devetashka cave. Caves in seismically dangerous areas with expected maximum magnitude between 6 and 7.5. These caves are Bachokiro, Rova, Čuka, Lepenica, Snežanka. Risk of flooding during heavy rainfall. These are caves Djavolsko Grlo, Ledenika, Lepenica. Dangerous, poorly maintained or difficult to use elements of the cave tourist infrastructure. This is also some danger. Magura, Ledenika, Seva, Dupka, Djavolsko Grlo, Lepenica, Uhovica. And caves with free access without an accompanying cave guide. These are Devetashka Cave and Bachokiro. And here you can see some other hazards for the tourism in the caves. This is the consequences of the global pandemic of COVID-19 during the closure of Bulgaria, which happened in 2020. You can see that there is a decrease of the amount of people which visit the cave, but because the cave is a closed space, there is a high possibility of contaminating of the air with some viruses and spreading these viruses. So the cave should be closed during such pandemics. So this is also some hazard for the development of tourism in the caves. So in conclusion, the sustainable development of show caves in Bulgaria requires a hard to achieve balance between economic benefits for those who manage tourist caves and socio-economic benefits for local communities, ensuring the safety of visitors and healthy working conditions for the staff working in tourist caves, preserving tourist caves and providing a visitor regime guaranteeing maintenance of an environment closest to the natural one for the karst geosystem, monitoring of the main parameters of cave system, including visitor monitoring carried out by the supervision of speleology, karstology professionals, transparency of the results of exploitation of tourist caves and of the monitoring of their condition, and also introduction into the Bulgarian legislation of terms, let's say, show cave workplace and profession cave guide in a show cave. Thank you for your attention.
Thank you, Professor Nuzarov, for the interesting presentation. I have one short question. We don't have too much time. These are your research findings, and they will be published in a scientific journal, but is it clear which is the authority, national or local, which might be interested in those results and to do something to reduce the risks?
I think that there are a lot of authorities, mainly municipalities, local municipalities, and also some government authorities maybe who work with let's say workplace safety, maybe who deal with the workplace safety. That's, yeah, say that.
So in my opinion, it would be good if you give them those results in Bulgarian.
Yes, they have some of the results, yes.
Some measures. Thank you very much. Do we have more questions, or we can go to the last presentation of the early morning? Thank you very much. So the last presentation for the morning session will be delivered by Dr. Bushnakov. Are you with us?
Hello. Yes, I'm here.
Hello.
Hello, everybody.
Thank you.
I will switch on my presentation now.
Okay. So Dr. Bushnakov is a structural engineer in the Department of Computer-Aided Design in the University of Architecture, Civil Engineering and Geodesy. He will deliver a presentation which is dedicated to the some approaches for earthquake damage reduction of age-reinforced concrete structure in Bulgaria. You are welcome.
No, Okay. Is everything okay on the screen? Yeah.
It's perfect.
Okay. This is a study by Professor Khargiev, professor in reinforced concrete structures in E, about the approaches for reducing the earthquake damages of reinforced concrete structures in Bulgaria. And we make a small review of the necessity of doing this. So what is the available building stock in Bulgaria? We made a recalculation of the available data because our census doesn't cover these numbers, and we found that approximately 73 and 75% of the residential buildings are not expected to withstand earthquake action because they were constructed under previous building codes, and from this total number, approximately about 5% are multifamily buildings, but they consist half of this total area. About 1/3 of the buildings are reinforced concrete structures. So it is necessary to consider the problem and to study it. How did these buildings emerge? So reinforced concrete is applied in construction since 1854. In Bulgaria, it was introduced around 1920, initially only for reinforced concrete floors, and after that it spread to beams and columns. In 1927, came into existence the first Bulgarian code of good design of reinforced concrete structures. About the seismic codes, the first Bulgarian code is from 1947. We had a major edition 1964. The next major edition came in 1987, and now we are under the 2012 last edition of this code. And at the same time, the Euro codes are adopted in Bulgaria. And some of these important developments in this code. In 1927, in Bulgaria was adopted the Italian code, and actually the 1947 Bulgarian code reduced the lateral forces initially provided. In 1961 was introduced the dynamic method. This is we are calling the response spectrum, the response spectrum method, and was implemented alongside the lateral forces. In 1964, this method became the major. The 1964 code was the first to introduce the utility to reinforced concrete frame structures, and the seismic zonation also was based on the MSK scale. And the bad thing is that the code was lacking some detailing requirements specific for seismic design of structures. Today, the Euro code and Bulgarian national annex is considering that the reference ground acceleration on sites is defined for probability of exceedance of 10% in 50 years, with a period of 475 years. And Eurocode, we are citing because it is state of the art actually. So it's considering 3 limit states. This is Eurocode 3 regarding the existing buildings. The so-called near collapse state, that is building is still, the structure is still standing, but its capacity to withstand next seismic actions is strongly reduced. The significant damage state for existing buildings that corresponds to the near collapse state for new buildings, because new buildings are with improved performance, and the damage limitation state. Actually, this is for practically operational buildings that shall be used during post-earthquake post-disaster operations. This is a small comparison of the ground accelerations from the different codes. As we can see, the code from 64 was using different ground accelerations for different soil types, while the approach that came later is to define different spectra and to have unique ground accelerations for the different corresponding to the different intensities. It's important to note, for example, we can see that for some soils and for lower seismicity, even structure, the earthquake loading was not considered, and the values are substantially lower than the current values in the new codes. Something that is implemented in all the codes is the importance class. It is recognized even in the earliest codes, and the initial approach was to relocate the building to a higher or lower intensity as per the importance of the building. Modern codes reflect that the buildings that are essential for post-disaster operations of those of primary importance for community life, housing places of large number of inhabitants, monumentals, and other facilities shall be considered with increased importance. General comparison about the classification in different codes is not necessary now to do, but the need to stress on the importance of buildings was recognized even in the earliest codes. The difference in the seismological, more general approach, and the engineering approach is that the seismological approach generally is describing the damages as global damages. This means both structural and non-structural damages. While the engineering approach is trying to identify structural damages and to assess the non-structural component separately. One of these approaches is, for example, by using the so-called damage indices. These are functions based on performance parameters that are normalized between 0 and 1. At 0, there are no damages. Usually, the 0 state is chosen to be at the beginning of the plastification process or end of the yielding state, and full destruction is chosen to represent a state where the building is approaching either non-collapse state or some percentage of lost structures. One of the first measures can be considered to be the ductility. This is the ratio between the ultimate displacement and the initial displacement at yield. So this is inverse. This is reciprocal value to the damage index. that I just spoke about, but this can also be normalized. This is a definition for the displacement ductility. We're recognizing rotational ductility, energy, hysteretic energy, and other ductilities. It's very important to stress on the fact that even the 64 code was using damping factor value of 0.5 for reinforced concrete, so from reinforced concrete structures. And actually this is implementation of ductility in early stages. Later this approach was developed both in local codes and also is present in the Euro code. This code specified factors are not describing only the ductility, but they also have some component that is including the so-called overstrength, the structural reserves that are not taken explicitly into account. Later studies led to this inclusion of this overstrength in the Euro codes, and the possible range for taking this overstrength into consideration is from 30 to 50% increase, but only for high ductility class structures that are specially designed with special detailing implemented for developing such overstrength and increased performance. The weak part is that in all old codes, actually, the detailing is not sufficient to provide this capacity to our structures. Here is a short example for a seismic upgrade, the necessity for seismic upgrade of a building constructed in 1964. The construction site was chosen for soil type 3 that corresponds to current C from the new codes, and the seismic zone has changed from the seismic risk assessment is increased from 8th to 9th intensity level of the MXK scale. The fundamental period of vibration before and after the upgrade for this example is fixed to 1 second to be able to show the differences and to make the comparisons. Here is how, for example, for this assessment, a damage index can be used. The example includes this De Pasquale and Jackman damage index. It's not some new development. It's well known for a long time, and it's based only on considering the changes in the fundamental period of vibration of the structure. This is the example. So here we can see on this graphics the development. The upper red line is the current Euro code and the current local Bulgarian code response spectrum that corresponds to both to these conditions, to these buildings. This is the elastic spectrum. So for buildings to take into account the presence of ductility, we are decreasing this values to ductility of 3 as it is described. Here we see the decreased response spectrum. The red and the intermediate red and green lines are the requirements or the demands of the possible earthquake loading on the structure. The lower blue lines are the design spectrum and ductility spectrum of the codes from 1964. So we can see the big difference in the requirements, big difference of the possibility that we can maybe about 2.5 or 3, 4 times even bigger seismic action, stronger seismic action on the building is required to meet under the new code provisions. And here with the brown lines, in the lower corner, we can see the capacities. The small brown line down around the 0 point of the graphics is the existing capacity. This is the required existing capacity of this structure constructed in 1964. And the dotted brown line is the required capacity after the seismic outbreak. So we can see the considerable difference. And actually, after making some recalculations in this example, here we can see that the final or the near collapse period of the structure was evaluated to be around 1.4 seconds. This is the change of the period of the structure within the performance range within ductility state, and it should be increased to 173 to satisfy the current code decision. We can see the considerable rise in the requirements towards this type of buildings. So what are the basic characteristics? These are the typologies and types. So are the ways of to classify the buildings according to different criteria. So by importance, by material, by structural system, and by technology of construction. So we are considering the castings in situ and the precast structures. The cast in situ structures are the frame structural system. We just saw example about this. Others are the so-called flat slab structures, large area formwork and tunnel formwork buildings. While the prefabricated are the lift slab technology that we're using up to 1990. Structures with precast floor panels and large panel buildings that are existing in our big cities. The frame structural system, I will not make very inside review of the system, but the important thing is that actually we have limited ductility to not more than 2. This is the ductility that we evaluate to be available to the original structure. Although the code for new structures requires a ductility of 4. For flat slab structures, they have predominantly reinforced concrete shear walls and staircases from this period. And even this value of 2 is can be proved to be too high. The large formwork area and the tunnel formwork buildings mainly used in high-rise construction, and generally these buildings are regular in plan and in height. This is favorable for their earthquake performance, and usually they have comparatively high structural stiffness. there exist some structures, some buildings that were constructed under the sliding formwork or slip form technology that was adopted from silos construction. Again, in these buildings, although they have improved quality of materials and technology, the ductility is increased. With lift slabs, we have some problems because this type of buildings, the Bulgarian adopted technology actually used column heights only one floor in height. This is a particular risk, and the
Professor, I apologize for interrupting you. Can you please wrap up because we are way over the program?
Okay, I'm finishing. So the approaches there, we have different approaches for the seismic damage reduction. We distinguish the global and local approaches, and okay, I will not consider all these approaches and how we can implement them. The important part that is that all these buildings need to be reviewed particularly, and we know the technologies. We shall provide a good strategy for efficient implementation of these technologies in order to solve problems with this type of building structure and the building stock. Okay.
Thank you, sir, for your valuable presentation. As I told you, we are way over our schedule, and the next presentation will be your presentation also. I would kindly ask you to have in mind that you have only 10 minutes for the next presentation, and we will put the questions after your second presentation.
Okay. I will reduce this.
Okay. So I will propose to have 5 minutes break. Hello again. We are back. Professor Pozhnakov, if you are here, I would kindly ask you to start your second presentation, and please be aware that you have only 10 minutes. I'm sorry.
Yes, I will be very fast. 1 second. Screen. This one. I don't see what is shared now. I'm sorry. Do you see something on the screen, please?
Not yet. Maybe you can stop sharing and start.
Oh, yeah, that again, yes.
Yeah, now it's okay.
Okay.
Sorry, we are not able to see your presentation yet.
Sorry.
Only the WebEx screen.
Only.
Yeah, now it's okay. Thank you, sir.
Okay, this is okay. It can be considered as a continuation of the previous presentation. So I will be as fast as possible and miss some of the slides. It's prepared by me, Professor Vasil Kargiev, and Professor Mihaela Kuteva from the University of Architecture, Civil Engineering, and Geodesy. A short review of the seismicity in Bulgaria. We had more than 30 events with magnitude above 6 and 10 of them above 7. We can see some of them. This is the first one in the previous century was in Shabla area. The intensity about 10 and it led to big destructions. Few years later, in the Kresna-Krupnik region, 2 events happened in a very short time with intensities 10 to 11. 10 to 11 to MSK scale. And they were comparative in power, although not in losses and number of casualties. To the Kahramanmaraş that we heard about. These are the devastations from the Gorna Oryahovica earthquake in 1930. City of Gorna Oryahovica, Veliku Târgovo, and other cities were affected. Sofia, okay, although not very affected by the earthquake I spoke about, was also subject to earthquakes, and we had some information about strong earthquakes that happened in Sofia area. This is the earthquake from 1917. This is the building of the Council of Ministers. Then on the 6th of September Street, we see partial devastations. 28 in Marica River Valley, there was a sequence of 3 earthquakes also, and they had strong damages. We are influenced by earthquakes happening in Romania, in the Vrancea area, and we can see some damages later. We had the Strahica event in '86. It was not very strong, but actually the number of damages was considerably high. Recently, we remember the Pernik earthquake. It was comparatively slight earthquake, but there are evidences of about 18,000 potentially damaged buildings in Pernik, and about more than 760 buildings with moderate and substantial damages in Sofia. That is not so close to the Berlin. We can say that after 1928, we didn't meet a really strong earthquake. I will miss this part about the construction codes and the different zones. This is a comparison of the response spectra of the current requirements. This is the local code requirement. The red line is the local code requirement, and the Eurocode requirement from our national annex is the black lines, taking under consideration also the Francian spectrum. We can see that even today, the local codes are lagging a bit behind the modern estimates. The exposure by population, we made some evaluation, and this is considering the major Bulgarian cities, and we can see the design levels from the historic seismic parts there are many investigations of seismic fragility and vulnerability, but generally it will be advisable to provide more local experiments on the capacities of structures. Generally, the methods we were speaking about, so we have the effect of strengthening. So how to improve by this global and local approaches we spoke before about to improve the structural performance, to enhance the deformation capacity of the structures. Applying base isolation greatly improves the displacement capacity, and also the modern approach of using seismic energy dissipating devices. Here we can see the different particular technologies we can use in strengthening to increase the capacity by applying different approaches by even doubling the existing capacities. Of course, we are having lots of methods for this task, and the conclusions of all this is that the modern perception has significantly increased compared to the time when major parts of the building stock were constructed. And from this short review of the past seismic activity of the country, we can say that we had passed a happy century for not having a really strong earthquake for this time. But this doesn't mean that we can have some rest. We shall implement the best knowledge and achievements to support the progress of the country. And in short, this is the presentation.
Professor, thank you for your informative and wonderful presentations. We have one question from the online participants. The time and the elements of nature have a strong impact on building. What are the effects of climate change? How it's possible to make anti-fragile buildings? Anti-fragile.
Okay, about the reinforced concrete buildings, we are considering the seismic part. There is currently going the program of energy rehabilitation. Our stress as a structural engineers, we are stressing on the structural problems, and we want to point also that only buildings that are safe in structural aspect need to be improved in other aspects like energy efficient. So anti-fragile buildings, the fragility is we cannot make the big buildings anti-fragile in this sense I'm speaking about, because the fragility is actually reflecting the probability of developing some state under particular laws. So we can. This is let's say probabilistic assessment of the building capacity, and that's why in this sense we cannot make buildings anti-fragile. We can strengthen the buildings to improve the parameters.
Yes, thank you once again. So if we don't have any other questions, we can move on to the next presentation, risk assessment for the city of Veliko Târnovo. Professor Dimitar Stefanov, if you are here with us.
Yes.
Well, please share your screen.
If you can share your screen, sir. And
do you see my screen? Do you see my screen?
Not yet.
Not yet.
If you, now. Yeah.
Okay.
Yes. Of course, I would kindly ask you if you can respect the time limit of 10 minutes, sir, because we are way over the program. Thank you.
Yes, of course. Okay. I will speak about risk scenarios in the beginning, and risk assessment and its associated management are the most effective approach to estimate the impact of natural hazards on the cities. The assessment of seismic hazard and generation of earthquake scenarios is the first step of seismic risk evaluation. The assessment of strong earthquakes consequences is based on procedures for integration of seismic hazard and seismic vulnerability of the bearing structures of the building stock. The present study focuses on the risk assessment for the city of Veliko Târnovo, which has experienced strong earthquakes more than 100 years ago. It was happened in 1913 with magnitude 6.8. And this earthquake was strongest on city seismic effects in the city of Veliko Târnovo. A few words about the methodology we used. The methodology is based on the empirical methods for determining the vulnerability of buildings using the approach in EMS 98. This is European macroseismic scale. To consider the specific features of the building stock in Bulgaria, a typology matrix containing 24 types of construction systems has been developed. Buildings are grouped according to their vulnerability class. Buildings of the same vulnerability class receive the same level of damage for a given seismic intensity. Based on this information, the social losses, number of injured people or death are calculated depending on what time the earthquake occurs, day or night, as well as the economic losses. The methodology requires that all information is available on GIS but is applied separately to each elementary cell of the GIS representation of the studied region. These pictures give information about the deterministic earthquake scenario for the city of Veliko Trnovo. On the upper picture, you can see the pattern of seismically. This is historical instrumental earthquakes bigger than magnitude 3, and of course active faults of this map. The next map shows, in fact, the seismic input for the risk analysis. This is presentation of the intensity in this net, which is correspond to macro to this earthquake 6.8. This information have been done 2 years ago. Is a different study of my colleagues, seismologists, and there is a special publication which is cited in the references. If somebody have interest, he can make a look at this publication. The first step is identification and classification of the building stock. In this table, you can see the distribution of buildings by pieces and total floor area by number of floors. You can see that almost 80% of the buildings are can be classified as low rise up to 3 floors. This table shows the distribution of number of buildings and floor areas by construction period. This is a very important parameter because it's the year of the design or construction is directly related to the current state of design seismic codes for the year. The largest number of buildings were built in period 1966-77. In terms of PFA, the maximum is in period 78-87. And based on the information about the cadastral design system, each building is classified in a separate type according to the matrix of topologies of the Bulgarian buildings. For Veliko Trnovo, the total number of typologies is 8, and the largest number of buildings fall in typology M1. This is masonry buildings. You can see the distribution here by typology and by number of buildings. Next step is evaluation of seismic vulnerability. The seismic vulnerability assessment is performed for each building individually based on information on its load-bearing structure, topology, construction time, number of floors, and other technical parameters. As you can see, the most of the buildings fall in class C, but there is a difference between number of buildings and PFA because the new buildings usually they are not so many, but their total floor area is big. Next step is assessment of direct damages on destruction. In this table, you can see the distribution of different damage grades: no damage, slight, medium, heavy, very heavy, and destruction. The building stock is divided in 3 main groups: residential buildings, administrative and public buildings, and special buildings: hospitals, schools, university, and kindergartens. And you can see the distribution between different damage grades. Next step is visualization of these damages on the map. You can see on the left figure very heavy damages here, and here very heavy damages. The most significant damages are observed in the central part of the city, by the areas near the river. There is a combination of 2 factors: the old buildings with high vulnerability and strong seismic impact intensity up to 8.5. Here you can see here is the turn of the river. This is Okay. For planning in advance the volume of restoration work, it's very important to know the distribution of unusable and demolished building in the three main groups. In this table, you can see the distribution of unused and demolished buildings, accordingly by numbers of PFA. The results clearly show that residential buildings are the most vulnerable, and with seismic excitation will suffer more damages than the other two groups of buildings. The demolished buildings in the special buildings are much smaller, one building, which is favorable concerning their importance after the earthquake. At last, there is assessment of social losses, injured people and victims. In this table, you can see the results, and usually at night, the injured people and victims are more. The reason is that at night, most of the people are at home. As you saw before, these buildings are more vulnerable. And the last step is assessment of economic losses. The total economic losses are about 276 million leva. The share of residential buildings is about 215 million leva. The losses in the special buildings are much smaller, which is favorable in terms of their importance. And finally, conclusion. In general, the city of Veliko Trnovo is located in the area characterized by high level of seismic hazard. The results clearly show that the residential buildings are the most vulnerable and will suffer more damage than the other two groups of buildings. And the built-up area of buildings without and with slight damage is approximately 36% and 33% respectively. The social losses are larger at night. Finally, it should be noted that adverse effect can be minimized as much as possible if a prevention action program is developed by the municipal authorities. Thank you for your attention.
Thank you, Professor, for your valuable assessment. I have only one question. For the buildings that are in a high risk, the population is aware that they are living in a dangerous building, and also if the authorities have implemented some measures in order to rebuild those buildings, or
The authorities, this information about the risk assessment is very valuable for authorities because they can create such program for rehabilitation and upgrading of those buildings which are most dangerous. In fact, according to our experience, it is not a good idea to say to the people that you are living, or your family live in a very dangerous building, because from social point of view, there is a very negative experience in Bucharest, because the Romanian colleagues, they announced to the people that some areas are very, very dangerous. And
that's the reason why I asked you this question, because I'm from Romania and I agree with you, yeah.
Yes. They said, we will never do this because there is a panic in the people. The prices of the buildings go down because everybody knows that this region is very dangerous. So I think that this information must be distributed very carefully, not to make people be afraid and be shocked. And this is information mainly for the specialists in the authorities to make prevention program, to plan the upgrading of buildings, and such kind of intervention in order to reduce the risk. In fact, the risk is losses. Losses are damages in the building, destruction of the structure, economical losses, and of course social losses, dead people and injured people. It's very nice to know these numbers and to organize hospital systems, first care systems, and people. There is people who will stay without shelter. Authority must know these numbers in order to organize the post-earthquake situation. Because if the strong earthquake is in the summer, it's very easy to make many tents. But if in the winter you need a warm place, shelter with heating. So these questions are very complicated and needs efforts of different kinds of specialists.
And one very short question from me. Do you know what is the distance between the earthquake epicenter and the city of the town of Veliko Târnovo?
I'm not able to answer now because, as I said, the seismological part is a completely different scientific study, and you can see the publication which is cited in the reference. I am civil engineer. I'm not able to answer this question because for me, seismic input is distribution of intensity across the area of the town. I am not familiar with any details about the seismic hazard analysis.
Thank you, Professor.
Thank you.
We will go for the next presentation of Professor Stoyan Georgiev. If you are here with us, you can start.
Yes, I'm here. I'm still not a professor, but thanks.
I'm sorry, sir.
Yeah, I'm just a PhD student.
Maybe you will become.
Yeah, hopefully. So I will start to share my screen. Yeah. Can you see my screen?
Yes, we can see it. It's perfect.
Okay, perfect. So I will present you our study of short-term effects of air pollution on hospital admissions in Bulgarian cities Sofia, Plovdiv, and Varna. And it's a project funded by the National Science Program Environmental Protection and Reduction of Risks of Adverse Events and Natural Disasters. So I will start with a short introduction. In recent years, the alarming rise of non-communicable diseases such as cardiovascular elements, diabetes, and respiratory conditions has emerged as a critical concern globally, including Bulgaria. In Bulgaria, the mortality rates of these diseases rank among the highest in European Union. This crisis is caused by many factors, relative low socio-economical status, underfunded healthcare system, aging population, and widespread behavior and lifestyle risks. And context in Bulgaria, compounding these issues, Bulgaria also faces severe air pollution with particulate matter levels being amongst the highest in European Union. These health challenges exert a significant toll on individuals, society, the healthcare infrastructure, and the broader economical landscape. Cities like Plovdiv and Sofia are notable for their exceptionally high estimated mortality rates attributable to fine particulate matter. And it's all reported by the Health Effect Institute. Here we can see the estimated number of preventable cases per 100,000 people. And you can see that especially also in Sofia, Plovdiv, and Varna, there are many numbers that can be preventable if we keep with the World Health Organization recommendation for air quality. Next slide is about the study objective. This study aims to analyze the short-term effects of air pollution on hospital admission for selected diseases in Sofia, Plovdiv, and Varna. The diseases investigated include respiratory diseases, ischemic heart diseases, cerebral infraction, and diabetes mellitus. This paper builds upon previous analysis, which focused on the short-term effects of air pollution on asthma, cardiovascular diseases, and diabetes in Sofia, extending the examination to include Plovdiv and Varna by pooling evidence from these three major cities. This study aims to offer a comprehensive view of the impact of air pollution on public health in Bulgaria. It also considers the unique topographical and atmospheric conditions of Sofia, Plovdiv, and Varna that intensify these pollution levels. Each city presents distinct climate and topography. Sofia is nestled at the foot of Vituša mountain, experiences a humid continental climate with cold winters and warm summers. Plovdiv is located in the Thracian plain, enjoys a moderate climate, continental climate, characterized with hot summers, mild winters, and Varna is a coastal city on the Black Sea and benefits from a maritime climate with mild winters and moderate warm summers. Now I will shortly present you our methodology. The data was collected from January 1st to January 1st, 2009 to December 2018, including major air pollutions like particulate matter, nitrogen dioxide, sulfur dioxide, ozone, and carbon monoxide, and corresponding daily weather records. Hospital admission data in Plovdiv and Varna were obtained from the National Health Insurance Fund in Bulgaria. Admission figures were derived from health insurance claims and were categorized using the World Health Organization International Classification of Diseases. Case numbers were then correlated with daily air pollutant concentrations. Then a negative binomial regression were used to examine the effects of air pollution on hospital admissions, considering a 7-day period prior to each admission. Then a method analysis was employed to pull risk estimates across those cities. And now I will briefly show you some of the results. Due to the time of the presentation, I won't go in many details, but here you see the estimated risk of respiratory diseases in Plovdiv, and you can see the different lags. The different lags mean how many days after the exposure is calculated the risk and is still persistent. And for example, in Plovdiv, nitrogen dioxide is showing a really big effect on the risk, on increasing the risk of respiratory diseases. And you can see on lag 0 values 1.04, which means that the risk of respiratory diseases in the day of exposure is increased by 4%. And then you can see that on lag 6, it's with 0.3, which means 3%. This is just for a short explanation, and I won't go in many details. In contrast, in Varna, sulfur dioxide is showing bigger effect on increasing the risk of respiratory diseases. And you can see that after 1 day of exposure on the second graph, that after 1 day of exposure on LAC 1, we have 13% increase of respiratory diseases, of hospital admissions with patients with respiratory diseases. And I won't go in more details than that. I will just show you the key findings and a short summary of the key findings. Elevated levels of air pollution correlate with increased hospital admissions for respiratory and cardiovascular diseases. Specific pollutants show stronger association in different cities, emphasizing the need for targeted air quality improvements. In Plovdiv, nitrogen dioxide consistently affected health outcomes on the day of exposure. However, particulate matter was only linked to respiratory diseases and CI at LAC 2. In contrast, sulfur dioxide had more consistent impact in Varna. Elevated levels of sulfur dioxide and carbon monoxide observed a few days to 1 week prior were associated with higher hospital admission rates for respiratory diseases. And sulfur dioxide also showed significant correlation with increased risk of CI and diabetes at some LACs. In the next slide, I will shortly compare our study with earlier works. Most of the earlier works are focused on Sofia, and they show higher air pollution levels observed several days before increase the risk of hospital admissions for IHD and CI. Correlation of particulate matter levels with the number of hospital emergency department visits, asthma prevalence, and other mobility outcomes. Increase of emergency ambulance services by an average of 10% during peaks in air pollution. A big contrast with earlier works is that previous studies used broader regional analysis and potentially overlooked local nuances. Local nuances can significantly affect air pollution dynamics and health outcomes. And this work incorporates a localized approach, examining specific cities with distinct environmental and topographical factors. And last slide about challenges and limitations. The biggest limitation is the lack of high-resolution quality data from air quality monitoring stations in Bulgaria, which causes also inaccurate assessment and response to air pollution health impacts. And there is a big need for improved air quality management informed by robust data and consideration of the unique environmental and topographical conditions of each city. And thank you for your attention.
Thank you, Mr. Georgiev, for your presentation.
Yeah.
We have one short question.
Yeah.
Can you tell us what might be the sources of nitrogen dioxide and sulfur dioxide? Are they internal sources here in Bulgaria, or we receive them from abroad?
Most of them, the big part of them, they're received from our industry, and nitrogen dioxide is mainly caused by the traffic, the traffic in the cities, and sulfur dioxide is mainly in winter, and it's due to the heating during the winter of the houses. So nitrogen dioxide is, mainly from traffic and from vehicles in the cities.
Thank you very much.
Thank you. I also I also have a short question for you. Here in Bulgaria, is there any existing platforms that provides real-time information about the quality of the air?
I'm not informed about that. There are some severe ones, which are like Air Sofia, but yeah, I'm not very competent on the question, so.
I can answer this question. There is real-time data which are published on the webpage of the National Institute of Geophysics, Geology and Geography, and it's about the air quality in Bulgaria and in 3 cities. I think Sofia, Varna, and Plovdiv, maybe.
Thank you. Thank you very much.
Thank you also.
I think we can proceed with the next presentation from the other part of the world, from China. If the colleagues are here.
Yes, I'm here. Can you see my?
Thank you, sir. If you can present yourself in a few sentences.
Okay. Good morning. My name is Chen Rui. I'm a doctoral student from Harbin Institute of Technology. Our team has been looking into how the brokers work in emergency networks. Ever since the Reagan administration carried out the idea of small government, there has been a ton of outsourcing and privatization, leading to the new public management movement, and it is called the age of networks and collaboration. When it comes to public emergencies, including natural disasters such as wildfire, earthquake, flood, and technical disasters such as chemical incidents and dam failures that cross boundary and cascade, they get complex real fast. They have low probability but high consequence. What is more, no single organizations or department can handle it alone. So we need multiple departments, government, business, communities, and NGOs to collaborate as a network. There is a key term called brokers. Brokers act like a bridge between two nodes in a network, helping to get information and resources moving. Check out the chart on the right from a famous paper published in 1989. It breaks down brokers into 5 types just based on where they belong. After going through the literature, we have noticed that there is not much research on how brokers evolve and adapt within emergency networks. The same goes for how they pass down information. So we get our research questions. How do brokers evolve over time? And how do they distribute the information during a crisis? The case we selected is a rain disaster in Henan province in China. Back in July 2021, the rainfall was off the chart, and sadly, it led to nearly 400 deaths. Direct economic losses amounted to over 120 billion yuan. We picked this one because the flood is cross boundaries and need collaboration from different departments. Moreover, it was a top 10 event that year. For our data, we analyzed the official report, news stories, and the social media posts. And we have divided the stages based on a governmental press conference. Stage 1 is a rescue, and stage 2 is a recovery. Of course, our method is social network analysis for the SNA. Manually, we screen the manuscripts that meet the research requirements and extract the subjects. And if there is a collaboration between 2 entities, it is marked as one. and the co-occurrence matrix is obtained. And then we use the UCNI software using the betweenness model to identify the brokerage nodes in networks. Here we measure the brokers by betweenness centrality, which is all about the shortest path in the network. Actors with higher betweenness centralities have more control over the network. We have got two stages of the network. On the left is the rescue network or response network. On the right is the recovery network. You can see the rescue network has more actors and connections. This table shows us the top 10 brokers in both stages. In the rescue stages, the blue one, number 1, number 2, number 3, and number 7 indicated that the government and the emergency department really took the lead. And the green one are Macau licensing office and the railway department. The Macau office is beyond my expectation. When I checked the news carefully, I found that many overseas donations were contracted to the disaster-stricken area through these organizations. They reach out to the world, coordinating donations, supplies, and all that. Moving on to the recovery stage, we still see the government and the emergency department play big roles, but there are some new phases too. Number 2, the education. Number 4, development and reform agencies. Number 7, civil affairs, and number 9, pharmaceutical companies are jumping in. Sum up, the evolution of brokers shows us how needs and tasks change. Each new department brings its own special resources and capabilities. We can use the structure host theory to explain how brokers pass down the information, originally developed by Ronald Stuart Bird. Let's break down these brokers into categories. The first group includes government and the emergency department. In China's hierarchical system, they are at the heart of the disaster response. Almost every organization links up with the core players to get the information and the resources they need. So we say they occupied the structure whole. Second group includes the weather service, railways, and the military. They can be explained by the resource dependence theory. They all bring unique skills and resources, like giving out critical weather warning information and shipping aid supplies to the affected area. For the recovery stage, the brokers still fit the resource dependence theory. Here, what we have figured out. The first one is the rescue network has more actors and connections than the recovery, and the government is a big broker. This tells us that China has established a highly centralized emergency management system with the government at the wheel. And the second one, when the tasks change, the emergency departments are still keep brokers, but we have got new players such as the education and the civil affairs because of their expertise in their field. The last one, the rapid dissemination of information by brokers can be understood through structural whole theory and resource dependence theory. Last page, here are some practical implications, mainly on how to improve the brokers. That is all my presentation. Thank you.
Thank you for your presentation. Also, your paper was very interesting, and I'm sure we can have many conclusions from the paper. Do we have any questions? If not, I think we can proceed for the next presentation of Mr. Georgi Sekov.
Yeah.
Mr. Sekov, are you here with us?
Yes, I hear you. Do you hear me?
Yes, very well. Thank you.
I'm trying to share my screen. Just wait a moment. Hello.
Mr. Sekov, please be aware that you have only 10 minutes because we are over for our schedule. Thank you.
Do you see my shared screen?
Of course, it's okay. Thanks.
Okay. My name is Georgi Tsekov, and I'm a PhD student in the National Institute of Meteorology and Hydrology. My supervisor is Associate Professor Elena Hristova, and she's also involved in this work. I will present you some information and preliminary results on first time in Bulgaria measurement of black carbon concentration in the atmospheric boundary layer by aerological sounding. And firstly, I will remind you what actually black carbon is. It's a carbonaceous aerosol. It's fine particulate matter with size usually less than 2.5 micrometers. It's also known as soot, or the black coverage we can see on the surfaces near continuous burning installations. An example, on an inner surface of a chimney. It is light and heat absorbing, which makes it a climatological active compound. It can provide as heating as cooling effect on the climate system. On the picture in right are shown the mechanism of how black carbon affects the climate. The prevailing effect is to warm the atmosphere, which makes it contributor to the global warming. The black carbon can stay in the atmosphere for periods from days to weeks, and its small size makes it harmful for the human health because the smaller part could penetrate deeper in the lungs alveoles and cause respiratory and cardiovascular diseases, as well allergic reaction. And that's why continuous expositions and breathing of highly concentrated air must be strictly avoided. On the picture on the left is a microscopic image of a black carbon with origin of vehicle exhaust. Exactly that type of black carbon is expected to prevail in the air of urban areas, especially in a big city as Sofia, with more than 1.5 million inhabitants. And there, where is the measurement site and where the experiment is conducted in the Central Aerological Observatory of the National Institute on November 20 in the late morning. The devices created to measure black carbon are called atomometers, and the principle they use to measure the concentration is based on the property of black carbon to absorb the light, mostly in the visible and near infrared wavelength diapason. In this case, the model MA200 of Microad company has been set to use wavelength of 880 nanometers. So there are two atomometers of this type used. The one measure concentration on the ground, and we call it for convenience the static one, and is situated on the spot 2 on the map. While the other is attached on a tetrahydrogen-filled balloon and elevated up to near 60 meters, and we call it for convenience the lifted one, and the starting point of his elevation is on the spot 1 on the map. Next to the lifted thermometer is mounted a radio sonde Vaisala in order to measure the altitude, but as well the temperature and the relative humidity of the air. These mobile thermometers have compact size and weight of about 300 grams, but also for comparison is used a third but stationary and more complicated thermometer, which is situated on the spot 4. It is in vicinity of intense road intersections, and higher black carbon concentration are expected to be measured. For evaluating the ground meteorological conditions, data from automatic meteorological station Vaisala is used, and the station is situated on spot number 3 on the map. The automatic monitoring station of Executive Environmental Agency on spot 5 provides hourly average data for other pollutants as nitrogen oxide, nitrogen dioxide, sulfur dioxide, and total particulate matter 10 micrometers or PM10. The weather on that day is defined by a low gradient surface pressure field with relatively high pressure over the western part of the Balkan Peninsula and low over the eastern part. The active baric formations and atmospheric fronts are relatively far away from the country. On the picture in the left is visible the routine vertical sounding a little more than 2 hours before our measuring campaign. And there is a morning inversion with height, morning temperature inversion with height of about 700 meters above the ground level. And these conditions are very favorable for retaining of air pollutants in the surface layer. However, during the experiment, the inversion was already destroyed, which is further visible by the measured values of the lifted radio sondes. And this graph represents the elevation in time of the lifted thermometer. The altitude is averaged for every minute based on data of the radiosoid Vaisala. This radio sound gives data for the height in every second, but is averaged for every minute because this is the time resolution set of the thermometer. So you can see that it is elevated fastly, left to measure on the top altitude for a while, and then gradually is pulled back using a reel with a step of 5 meters according to the preliminary made markers of the line which connects the balloon with the reel on the ground. So on every 5 meters is left to measure for about 5 minutes. These graphs show the meteorological parameters. The first one, shows the temperature dynamics on the ground level with red dots and temperature measured by the radio sound with blue. As expected in already non-inversive boundary layer, the temperature in height is lower than this on the ground, but both are rising due to diurnal march in that mostly sunny morning. The second graph represents the relative humidity march, which behavior is opposite to the temperature, which is well expected. The third graph represents represents the wind's behavior on the ground during the experiment, averaged for every minute. The direction, as it can be seen with red dots, is almost constant from south-southeast. The velocity varies from 0.8 at its lowest to 1.6 in the beginning of the experiment. It can be defined as very weak wind, allowing the pollutants to stay longer in the ground level. And here is the essential part of the measurement, the concentration of black carbon measured by the mobile iotometers with black dots are the values from the lifted one, and with white triangles the static one. Generally, their averaged values are relatively close. A little higher are these from the lifted one. There are significant difference in the beginning of the experiment when the balloon begins to elevate. To me, it was an unexpected bad surprise. I was hoping that these values will be similar. My only explanation is that the starting point of the lifting device is closer to the parking lot of the institute. The both iotometers measure relatively high concentrations in the period when the ground level wind is at its lowest velocity, as it's seen in the previous graph. At the end, when the both devices are on the ground level, the concentration values are almost equal, something I was expecting as well in the beginning. But most probably there were some vehicles parking and the black carbon particles have affected the lifted iotometer, which proved the horizontal non-homogeneous distribution of this pollutant. And the second graph on this slide is another proof of that. As I mentioned, there is a third stationary and more sophisticated iotometer, AE33 of McGee company, which is situated very close, about 50 meters to intense road intersection. And as it's visible, its concentration with blue line is significantly higher than the lifted and static one, which are more distant from the road. So the next graph shows the march of concentrations of other pollutant measured by automatic monitoring station of Executive Environmental Agency for the entire day. They are hourly average values, and with bars are shown the black carbon concentration measured by both mobile and the stationary iotometers. It's a little bit confusing because of the different scale ranges, but on the next graph, where the scale is relevant for all the pollutants, is shown the black carbon concentration dynamics and hourly averaged values of other pollutants for the same hour periods. For us, was important to estimate what is the part of black carbon concentration relative to total PM10 concentration, and it is about 20-25%, which corresponds with previous independent researches on that topic. For conclusions, the results of this experiment show similar concentrations on the ground level and in the layer up to 60 meters. It's confirmed the dependence between the distance to working cars and vehicles and the black carbon concentration. And it's also barely confirmed the reversed correlation between the wind speed and the black carbon concentration. For me, the main conclusion is that such type of measurement is possible. the battery life of the mobile iometers allows the measuring session to reach more than 4 hours, and the balloon can be elevated much higher, up to 300 meters. But in this case, the vicinity to the airport makes it inappropriate, or at least not always possible. The size and weight of the iometers allows to be mounted as well on an unmanned flying vehicle as drone, and in the future this method will be also tested from us. So thanks for the attention.
Thank you for your presentation. I don't have question.
One short question from me. Is there another type of carbon instead of black? Is there red or white carbon?
No, there is a brown carbon, and it is formed by burning of biomass, or
Is the main source of the black carbon?
the main source of the black carbon are the internal combustion engines, as well the domestic heating with biomass.
Thank you. Ready?
If we don't have any other questions, I think we can proceed with our last presentation of Professor Dr. Engineer Peter Pavlov. Sir, if you are with us. Professor Pavlov, are you online?
Sorry, my phone was not switched. My name is Peter Pavlov. I'm professor in the University of Architecture, Civil Engineering and Geodesy, Department of Technical Mechanics. I'm head of the Lab for Numerical and Experimental Dynamic Modeling in the department, and head of National Earthquake Engineering Center. This paper is part of work of my PhD student. Sorry that he don't have possibility to share the presentation due to family reasons, so I will present the title. I will share my screen. Do you show my screen, my presentation?
Do you prefer we to share the screen, or you prefer to share by yourself?
I share screen. Do you show
Yes, we can see it. Yeah.
Thank you. The name of the title is an experimentally oriented approach in assessment and improving the seismic behavior of a class of non-engineering designed and constructed buildings. This is a common presentation and title paper for me and Radoslav Nikolov, PhD students in our department. The topic of this paper is part of the PhD thesis of my PhD students, which include an investigation of a class of non-engineering buildings. This is buildings which are manufactured from stone, from masonry, and some other natural materials. And this type of houses are very distributed in the different areas in Bulgaria. In this paper, we will consider the masonry buildings, small masonry buildings. And the goal of this presentation is experimental studies of them. So before experimental stage, we have to make some preliminary investigation and research. We have to create a building model of a given house. We have to precise statics model of the system, dynamic model. Sometimes we have to make some preliminary analytical solution, some numerical solution based on the mathematical programs, on programs in finite element methods. And finally, we go to the experimental study. These preliminary stages help us to precise scale of the experimental model, characteristic of materials, and some other elements of the experimental model. So when we have to investigate one natural house, first we have to prepare a building model. We will show a typical house from masonry in Bulgaria. Next stage is to precise the static model of the system. We have to be thinking about the connection between columns and base, between columns and roof, and to specify if the connection between elements of the building is close to the joint connection or is close to the rigid connection. We are going to show this in these two drawings. We need to show different static models. First figure is static models which are close to the rigid connection, and the second is closer to the joint connection. Next stage is to precise dynamic model and to determine the value of the mass that we have to include to the roof level of the system. Next, we use sub program for some preliminary study about condition of the system with or without reinforcement. In this slide, you may show the plane and space model of the typical house without reinforcement. Next, we may to show some model with reinforcement. We use horizontal or vertical or mixed system for reinforcement of the system. Next, we may to show some study of the deformed shape of the system after the vertical reinforcement, after horizontal, and in the next slides after mixed reinforcement. This preliminary numerical study helps us for precise the final experimental model. Here is the drawing of the experimental model. The left part of the drawing is about unreinforced model, and the right part is about reinforced model by mixed column and beams. We are located in the outside of the building with the goal not to change the external view of the house. Some of the text in this drawing is in Bulgarian because this is drawing which is for company that will manufacture the experimental model. Next, we need to show the experimental model. We use scale about 1/5. We cut the bricks on 5 parts, and the scale is 1/5. We input some window and door in the model. For roof, we use one wood, and we include mass. We need to show mass over roof. This is photos experimental stand. The experimental element and model that we need to show is scale model of the building and shaking table with 1 degree of freedoms. Direction is given of the action of the shaking table. This is another drawing. We need to show distribution of the accelerometer. 1 accelerometer on the level of the shaking table, 3 accelerometers on the wall, and 1 near to the roof. We made to show view from above. Here in this red drawing is the distribution of the masses. Here is some steel elements for moving the experiment by crane because the the mass of the weight of the experiment is about 1 ton. It is photos of reinforcement of the model by beam. We may show beam and maybe columns in this dark part of left pictures. And maybe interesting is some video of the experiment. We may show. It is very old system which working on DOS, not on Windows. Those old programs are manufactured before maybe 30 years. And unfortunately, in Bulgaria, this is the only good shaking table for experimental study in electrical engineering. Maybe next video is maybe some good view. We need to show the motion of the system, the changing of the crashing of the element. We increase the frequency of the impact and stop when we show that buildings start to crash. And next we need to show some results, the analyze and the results follow in the final part of dissertation of my PhD student. We need to show here first in this slide registered acceleration during this resonance test, some part of acceleration and registered acceleration during harmonic excitation of the building, and next of the scale building. And next, this is after reinforcement by this mixed system. We made to show the new frequency in the respective periods, show the new amplitude of the acceleration and some other. So this is this presentation by this experimentally investigation of this type of buildings. Experimental model help us for precise the numerical model help us to use some good to precise the parameters of the experimental. These two methods, numerical and experimental, help one to other to receive very nice results about the investigative approach. Thank you very much for your attention.
Thank you very much. It was a really interesting presentation about such modeling, real modeling with a shaking table. You are dreaming to have a new laboratory complex with a big new shaking table. Can you share your plans with us?
Yes, I have good video, but I'm not ready for now to present.
Just 2 or 3 sentences.
If you want,
I talked about this yesterday, but you can tell us again.
On today afternoon session, I made to share this film to show if you have time.
Now we don't have time, but you can share this in the WebEx platform.
Okay.
Do we have any other questions?
On the platform, we don't have any other questions, and I think we are close to our panel. So
yeah.
I want to express my deepest gratitude for all the panelists for your contributions, and we explored the complexities of the natural and human-induced hazards, and also we examined the pressing issue of air pollution and the impact on health. I encourage you to continue this conversation and to apply the knowledge and insights gained here in your fields. And I want to thank you once again for your time and dedication.
I also thank all the presenters. Instead of presentation, they have provided very good papers which will be published in the conference book. We will have a lunchtime break, and after the lunch, we will have another portion of good presentation. So I encourage you to continue watching our conference. Our next session will start maybe 1 hour in 1 hour, and we will have two presentations delivered by young scientists. So I invite all of you to be with us in 1 hour time. That's all by us. See you soon.
Thank you. See you soon.
Най-вероятно. Чакайте сега. Дайте като гест.
Okay, we are going to start the next panel, the next session of the annual conference, and the main topic of this panel is high performance computing, modeling and simulation, again, geographical information system and AI, this so powerful instrument used nowadays. So our first presenter is the PhD candidate Dilyana Hristova. Is she online? At the moment we don't have...
We can't hear you.
Hello. Can you hear me?
Now, yes.
Okay.
Could you
share my
first,
screen.
First, could you present yourself briefly?
Of course.
And you can...
hello, everyone. My name is Dilyana Hristova, and I'm a PhD student at the National Institute.
Okay, so Dilyana, please start your presentation for the interseismic monitoring via DINSAR methodology in a German fault zone.
Can you hear me now?
Yes. Can you start
Okay, do
sharing?
you see my screen?
Yeah, but you need to make it in a presentation mode.
Yes, of course. Okay, now everything is okay, right?
Yeah.
Yes.
Okay. So, hello everyone again. My name is Dilyana Hristova, and I'm a PhD student at the National Institute of Geophysics, Geodesy, and Geography. Today, I will be presenting my study on interseismic monitoring using the EnviroRisk in Bulgaria. I would like to thank the National Geoinformation Center, founded by the Ministry of Education and Science of Bulgaria, for the support. So, here you can see an overview of the topics we will cover. We will discuss this research, briefly explain the INSAR methodology and the interseismic period. Then look into the analysis. Now we will take a look at the analysis operation performed, leading us to the results of the study. Finally, we will discuss the advantages and disadvantages of the method. So, INSAR is one of the newest methods detecting and measuring tectonics. It's primarily applied in areas with high and very high rates, such as San Andreas Fault and Fault. The primary motivation in this method is to understand seismic energy accumulation and improving long-term earthquake forecasting. We Bulgaria for study presenting results of an active fault during the with this method. And firstly, I want to discuss with you what the INSAR is. The differential synthetic aperture radar interferometry, or INSAR for short, represents a type technique. It is based on the principle of interferometry and uses microwave radar signals generated and transmitted from satellites radar sensor. Upon reaching out, the signals are reflected back to the satellite. Subsequently, they undergo processing and texting information about surface characteristics and terrain deformation. After understanding what INSAR is, let's look at what interseismic entails. In this part of the seismic cycle, referring to the observation that earthquakes repeatedly rupture a given part of a fault, of course, the cycle does not imply that earthquakes are periodic or repeating. The seismic cycle can be divided into three periods: interseismic, seismic, and post-seismic. The period this study focuses on is the interseismic one, which is highlighted on the right side of the slide. And this period is the time of slow accumulation of elastic stress that coincides with frictional movement in earthquakes. This fault allows the period or earthquake, and after that comes the post-seismic period, lasts 2 years after an earthquake, when crust and fault both are are still adjusting the modified state of crucial stress caused by the earthquake. So let's see the objectives of my study. The primary objective of the study is to apply the INSAR methodology for monitoring and analysis of surface deformation in the German fault zone. The specific groups are two. The first one is detecting the ground surface deformation using the INSAR and generating interference and visualize patterns. And the second one is to analyze information patterns, understand their and the fault. Achieving tools will provide valuable insights into the accumulation of seismic.
Sorry for the interruption, but the sound quality is not so good. Could you keep the mic closer?
So, present you the German fault. You can see it on the screen in red line. The subject of the study is a fault located in southwest Bulgaria, of mountain, and through the southern parts of the Spalid and Separeva-Bania. And it's considered as a potential seismic source. From a geological perspective, the fault is part of the River Rodok Massif, the northern part of Aegean province. It has the characteristic typically for normal fog with southwest northeast orientation and a length of approximately 10 kilometers. As I mentioned on the previous slide, which is one of the most seismically active. The next slide, we will see the data and which was used in this study. It's used free data from Sentinel-1 mission of the European Space Agency available at the Sentinel Hub. On the top right side, the used product. It is a ferrometric wide swath product, which is effective for providing for length observation. There's coverage of 280 kilometers and a spatial resolution of 5 meters. The period covered by the radar is from 2015 2022, the earlier temporation. In the analysis, there were used two software products. First one, the application platform or for short snap. It's a software platform for processing satellite images. And the second one is maybe used more like plugin in Snap, the so-called network for algorithm for ethnographic for short snap view for the processing of ground. As you can see on the slide, various analytical procedures have been carried out to process export the data. This involves several stages, including initial application of specific algorithms and models, list of the results, and interpretation information. And now, finally, let's clarify what the program actually is. Simply put, interferogram is the phase differences between two radar images on object, but they at different times. To create an interferogram, the images the reference order one is cross-multiplied with the second one. The amplitudes are multiplied, but the phase differences represent. See here on the top of the slides. The phase is calculated from several main factors such as Earth's curvature, surface of the Earth, and spherical conditions. And when calculating the phase of the interferogram, it's assumed that the phases of the Earth's curvature and topographic phase are the same in both images. So they're just excluded from the calculation. And now let's see the results of the study. A total of 14 interferograms were generated to analyze the interseismicity in the German code. It includes templates with two interferograms created for each period, one from an ascending and one from a descending orbit. Temporal intervals were captured. Through their analysis, oscillated the German code, which can be grouped into two models. The first one you can see on the top left. It's a model of slight substitution of the real massive and properties of the Topnitz-Nielsen programs from descending orbit. The second one, on the right side of the slide, is actually not be associated with the ball in the fault zone, of course. And the third one, shown in the middle of the slide, is the uplift of real mass of the basin. This model is based on analyzing the results from two interferograms. One demonstrates the highest degree of efficiency. It's from the ascending orbit and covers the period from earlier 2019 to earlier 2020, and the observed movements corresponding to this model mainly affect the areas sound pitch removable. Down the road between victims of some of the you can see it over it here in blue. And now it's very important to say that having discussed the result, it's essential to consider both the disadvantages and advantages of the methodology, as it relates to our findings. The results from satellite images from ascending orbit, perspective of the study. The results still remain controversial due to in the divided groups, which are technological. The first group is equal to the logical aspect, the lack of precipitating of the season period of the unfold, and the large impact of which was needed due to the specific requirements of the study of small accumulation the longest possible observation period. The second group includes technological aspects such as terrain type and information that can be detected. And these factors can be contribute to inconsistency and unclarity in the results, further complicate the interpretation. But despite these challenges, the INSAR offers several significant advantages. The first one is to become a primary tool for monitoring interseismic deformation. It's ability to detect and measure small group movements, making it available for understanding seismic energy accumulation. The second one, the continuous improvement of the INSAR technology, what allows the possibility to extend the period to more observation, and this is a show for capturing on the term deformation. The last one, third one, unlike other methods, the INSAR does not depend on tape condition. These programs be created regarding whether there is snow cover or if it's nighttime or daytime, and this provides a large flexibility in collection. In conclusion, this study showcases a modern approach for interseismicity. 7-year period in the German fault area. It's using 14 interferograms annual deformation, for which the sending bit has proven to be 1. Currently, for areas with low stress accumulation rates, such as the German fault region, from my can be used only for the of interseismicity, because the technology is not yet advanced enough to provide the comparable approach to this region with high stress accumulation rates, such as San Andreas fault. No. And for those interested, there is a connection available with interested from all times used in the study, providing further insights, data, and analysis. And if you have any questions or comments, please feel free to ask that at christovagiu.com or LinkedIn. My name is Ileana Christova. And finally, but not least, your attention and
Thank you, Dilena, for your contribution. The microphone was not operating well, but can you please give us more detail about the methodology you used? It sounds very nice. The one with 14 years in 1 year, the very last slide, I believe, or before the last slide.
Yes, of course. A second. Now you can see my slide.
Yeah, there was one slide saying on the right side, 1 year, 14 years, that part.
I understand this one. Yes. In this study, I used 14 interferograms. So this is 28 radar satellite images, which capture period from earlier June up to next year, earlier June. For example, earlier June 2019 up to earlier June 2020. And I need 2 satellite radar images to combine and make one interferogram. Is that answering your question?
Yeah. Just your microphone was not operating well, and I couldn't understand if it is what is the details. Thank you very much.
Another question. What is the resolution of the radar?
Yes. The resolution of the radar is 5 by 20 meters for one cells.
Okay, thank you.
Here, okay.
Yes, thank you very much for this presentation. Please stay up until the end of the session. There is one more presenter. If we receive more questions online, we will ask in the end of the session. And now we want to invite Desislava Kostadinova-Hristova, who is working as geographer in the National Geoinformation Center at the National Institute of Geophysics, Geodesy and Geography in Bulgarian Academy of Sciences. She's a PhD candidate in the institute, majoring in cartography and GIS. Desislava completed her master's degree in 2018 in Sofia University at the Faculty of Geology and Geography, majoring physical geography and landscape ecology. Her scientific interests are focused on the field of ecosystem ecology, ecosystem services, ecosystem accounting, spatial analysis, cartography, and remote sensing. Her presentation title is Comparative Analysis of Topographic Conditions of Hydraulic Flood Modeling Using Different Spatial Resolution Digital Terrain Models, a case study from Augusta River, Bulgaria. Desislava, the floor is yours.
Hello, we are glad to be part of the conference. Can I share my screen now?
Yes, please share it.
Only WebEx meeting window. Okay. Could you see my screen?
No.
See. This is her screen.
This is your screen, but we don't see your presentation.
Ah, okay. What about now?
Yes, and you need to use the PowerPoint, the presentation mode.
Yeah, slideshow.
Yes.
Okay. As I said, we are glad to be part of the conference. Before we start, I want to introduce us quickly. My colleague Davis Dinkov and I are part of a team from the Geospatial Research and Technology Laboratory at the Geoinformatics Center in the National Institute of Geophysics, Geodesy and Geography at Bulgarian Academy of Sciences. The topic of our today's presentation is comparative analysis of topographic conditions for hydraulic modeling, fluid modeling using different spatial resolutions, digital terrain models, a case study from the Augusta River, Bulgaria. This presentation contains the following structure: introduction, study area, materials and methods, results, discussion, and conclusions. A number of studies have shown that high spatial resolution of topographic data is prerequisite for more precise and accurate hydrological and hydraulic modeling. The high resolution and precision of an image or spatial model is a good starting point for fluid modeling. The details of the real surface are extremely important in such studies, since any natural anthropogenic object can influence to some extent the character and the strength of the fluid. The study area is located near Gorna Kovačica village in Montana province, northwestern Bulgaria. The territory covers a section of the upper stretch of the Augusta River Valley with a length of 6.5 kilometers. This section was chosen because, first, there is a hydrometric station to measure the river water levels and groundwater. Second, it has taken a LiDAR survey in 2013 under the ASCOR project, as well as unmanned aerial vehicle surveyed since 2019 under the TopoMet project. And third, the topography of the study site is suitable and accessible for field survey and mapping. In this study, 3 terrain surfaces with different spatial resolutions are considered regarding topographic conditions for hydraulic fluid modeling. BG, a digital surface model, or DSM, was created by Bulgarian Ministry of Agriculture and Food, and it was produced by aerial photography and traditional post-processing. This DSM was produced with 4 meters resolution. As we can see from the screenshot, the riverbed is not even delineated. LiDAR Digital Elevation Model, or DEM, was developed for the National Institute of Geophysics, Geodesy and Geography at the Bulgarian Academy of Sciences by an Austrian team. The airborne laser topohydrographic scanner was used, which is designed to survey seabed and land surface of rivers or lakes. This DEM was produced with 1 meter resolution. SFM DEMs were created by a team of scientists from the mentioned institute. A Winkter 1 VTOL was used, which is a mapping drone equipped with a Sony camera with a 35 millimeters full-frame sensor and 42 megapixel resolution. After photogrammetric processing, the images, terrain surfaces were prepared with 1 meter and half meter resolution. Ground control and validation points were used to control the processing and assess the accuracy of the terrain models. The accuracy of the field surfaces was evaluated using QGIS software. The X and Y coordinates of the validation points were entered using a point shapefile. Subsequently, Z coordinates were assigned using 2D coordinates, DSM raster, and the point sampling tool plugin. The resulting coordinates were exported as a text file and compared with the reference position of the validation points. The figure with letter A represents a scheme with all ground control points marked in red triangles within a white circles and validation points in yellow crosses. The table shows vertical root means square errors for point position acquired on digital elevation models in meters. The mean square error in height is over 2 meters for BGDSM and under 30 centimeters for the other DEMs. The attached histogram on the left shows the vertical errors at the validation points, which explores the accuracy of the BGDSM terrain surface. The errors in height range from +1 to -4 meters, which together with the precision of the allows us to conclude that this DSM cannot be used in hydraulic studies. This enclosed histogram on the right display also the elevation errors in the validation points for LiDAR DEM and SFM DEMs. The height errors in the 3 models range from +20 centimeters to -20 centimeters. The figure shows several significant deviations in the error found in the ground control points 5 and 12 and the validation points 10 and 24, which is because they were selected on artificial structures protruding above the terrain, and when modeling the DEMs, these objects were removed. In the rest points, we have homogeneous of the surveyed surfaces. For the simulation of the river flows, the Flow2D plugin for QGIS was used. This tool develops formats, analyzes, and displays data used by the Flow2D model, which is the two-dimensional fluid routing model. The model can simulate channel flow both in one dimension using cross-sections and in 2 dimensions, generating raster images with max flow depth values for each grid element using the rasterizer by Flow2D. This is what the plugin looks like in the QGIS environment. To perform comparative analysis of topographic conditions for hydraulic fluid modeling, we use digital elevation models with different spatial resolutions, which we have already mentioned, and simulated hydrological conditions with different water quantities. Before running the Flow2D model with the various simulations, we had to set it up going through 8 basic steps shown on the figure on the left. One of the most important steps of the process for our study was setting up the cross-sections, which were determined naturally relative to the riverbed, and some of them were selected to precise locations due to the presence of measured ground control points, and also due there being a hydrometric station that measures water level. The difference between the LiDAR dam and SFM dams inside the channel shows the morphological changes occurred between the 2 acquisitions, which are 6 years apart. The reddish areas were certainly deposition zones up to 200 centimeters accumulated in this period without considering the vegetated areas. Bluish hues represents either erosion areas or areas during the SFM survey, or wet areas, sorry. The differences between the channel morphology from LiDAR dam and from SFM dams are visible in the river cross-sections in the next slides. In the figure shown, a higher height, the bridge, is depicted in red, which was being removed in SFM dams and remained in the surface structure in the LiDAR dam. For hydraulic modeling, 2K sections have been selected, the first at the bridge and the second at the hydrometric station. The blue pin shows the location of the input hydrograph we set in the model, while the red pin shows the location of the output hydrograph. Numbers indicate the location of the cross-sections profile. As mentioned above, Flow2D can simulate the channel flow in 2 dimensions, but in our case, the river flow was simulated in 1 dimension with its geometry represented by natural cross-sections. In total, we placed 49 cross-sections along the study site of the Augusta River. We then selected 4 of them as the most representative. In the figure on the right, surrounded by red circles, we have shown their locations. In the figure on the left, you can see the outlines of their profiles relatives to the different surfaces of the LiDAR dam and the 2 SFM dams. The biggest difference in the drawing of the profiles with the different dams we reported in cross-section 242, where for 6 years its deepest parts have been filled in order to approximately 2 meters excess. Here it should be taken into account that LiDAR dam captures river underwater topography, hence the large variation of the riverbed, and the actual sediment accumulation cannot be such a high order. For the simulations with different water quantities, 2 profiles were selected. The first is located just before the bridge, and the second is where the hydrometric station is located. LiDAR dam was used as the base topographic surface with which river flow simulations of 15, 20, 30, 50, 100, 150, and 300 cubic meters per second were made. As can be seen from the graph, even in the first simulation with 15 cubic meters per second, the left bank of the river is flooded. For the SFM dams, the right bank is in this cross-section is flooded at an inflow rate of 30 cubic meters per second, while for the LiDAR dam, it is flooded at 100 cubic meters per second. The bridge level is flooded at the maximum tested water quantity of 300 cubic meters per second. This situation is completely different at the second selected cross-section, where the right bank is lower than the left. The maximum water surface elevation is when a simulation of a water quantity of 150 cubic meters per second that does not exceed the left bank. Still in the simulation with 300 cubic meters per second, the water goes outside the riverbed and the right bank is flooded by 100 cubic meters per second. Two-dimensional fluid routing model, Flow2D, can be used in relatively natural territories, such as the present one, as it gives satisfactory results in two directions for which we tested it. First, comparison of the cross-sections obtained from 3 different topographic data, and second, display the water levels in cross-sections from the simulations with the different inflow rates. In conclusion, given that the differences in the outlines of the considered cross-sections from the different topographic surfaces are not large, it is not expected that there will be significant differences in the simulations for them with the same inflow rates. Of course, this is a good starting point for a subsequent study regarding the changes in the maximum water quantities for the selected cross-sections. The generally high spatial resolution and accuracy of topographic models is an important prerequisite for accurate and reliable hydrologic and/or hydraulic modeling through software simulations. And now I thank you for your kindly attention.
Thank you very much for your nice presentation, this is Wava. I have a question for you. You presented cubic meter waters, but do you have estimation which cubic meters correspond to 100 meter probability wave, 500 and 1000 meter probability, the probability waves which are the normal modeling for the float events? You show one. Yeah, in one slide there were the cubic meters of the water discharge.
Here,
Here, exactly. So 300 meter cubic meter per second. Do you know to what extent can be corresponded to the 500 or to the 100 probability wave?
Maybe it can be visible in two-dimensional modeling with this QGIS plugin, because the outputs of the profile are of the simulations of the two-dimensional modeling are raster images, and there can be shown the fluid, extent of the fluid.
Okay, thank you.
Okay.
And I have also a question.
Okay.
Because the floodings are something very dangerous nowadays because of the climate change, etc., etc. Many countries have risk reduction strategies in which floodings are high priority dangerous events. My specific question is, how easy is to produce a prediction to assess the risk for specific region, for specific municipality, for example, using these methods?
This is a nice question also. So I think it will be easy if we have quality data.
Okay, we don't see any online questions for you. So thank you once again for your nice presentation and replies of the questions. Yeah, with this, our session can be concluded.
Thank you.
Thank you.
There is no break in the agenda, so the next session will start immediately about waste management and water resources.
Good afternoon, everyone. I'm Colonel Kamen Ivanov, and together with Professor Stefka Fidanov from the Bulgarian Academy of Sciences, we will moderate the next panel, which is dedicated to water resources. At the beginning of this session, I would like to say that everyone, even he is or she is not an expert in the area, they should be care and should dare to know how we are able to protect our planet. Of course, it's very difficult to prevent natural disasters. However, we're able to predict them and respond adequately. This forum is an exceptional place for sharing ideas and scientific approaches, how it may be achieved. And now I will give the floor to Professor Fidanova to present the next panelists.
The first author is Milena Mitova, if Milena is online. She is from the Institute of Soil Science, Agrotechnology and Plant Protections, Department of Physics, Erosion and Soil Biota. His field of research is working with the SWOT model, and she also works with the models for predicting water erosion and mapping the factors and the risk of street water erosion. Okay. Milena, you can share your screen. Is you online?
Did you hear us?
Milena, are here? No answer. I think yesterday evening she sent her his presentation. Next. Okay. If the next presenter is online, Kalin Seymenov. Milena is here. Okay. Let's start with Milena. Milena, you can start to present your talk. Good. Okay. Let's switch to the next presentation. I think Kalin Seymenov sent his presentation several days ago. Okay, next presenter is Kalin Seymenov. He has a PhD degree in hydrology from the Faculty of Geology and Geography of Sofia University. He currently works as a geographer in the Hydrology and Water Management Research Center, National Institute of Geophysics, Geography and Geology at Bulgarian Academy of Science. His main research interests are focusing on hydrology, water resources and water quality. Kalin, you can start your presentation.
Dear colleagues, are you here?
We hear you. You can start. Your presentation?
Yes, we can. Okay,
we hear you. You can start.
Okay, the topic of the presentation is trends in the use of water resources in Bulgaria. We are Kalin Seymenov and Gracia Kocheva from Hydrology and Water Management Research Center, an institute of Geophysics, Geodesy and Geography and the Bulgarian Academy of Sciences. Introduction, the renewable fresh surface and underground water resources in a given territory are determined by climatic conditions, geology, land use, transboundary.
Please, Kalin, click on full screen of the presentation. Full screen of the presentation, click.
Expand to your presentation, please.
To be on full screen. Do you hear me?
Yes, it is in a full screen.
Click on show presentation and it will be on full screen.
Stop sharing and share it again.
Stop sharing and... Okay. Stop sharing and share your presentation again and click to be on a full screen. Okay, now start sharing the presentation. Click. No, it's not a full screen. On a top, there is a button show presentation, presentation show. Click there to be in presentation mode.
If you go down on the right side, there is one mark in order to show the whole presentation on the screen. Anyway, we can continue.
Continue.
Okay, and the reformation of the political system over the last 30 years, the legislative changes after Bulgaria's accession to the European Union and continuous relations regarding climate change, the Green Deal and others, have significantly amended the economic and investment policy, negatively affected demographics, and has influenced on the demand and of the freshwater resources. The freshwater resources in Bulgaria are mainly formed by external inflow and are unevenly distributed over the territory of the country. The present study aims at making an analytic review of water use in Bulgaria for the period of 1990 to 2020 by economic sectors, while clarifying the relevant trends. The analysis is based on the published data by the National Statistical Institute, and the obtained results will justify the main conclusions regarding the general and sectoral water use at the national level in the study period. Data and methods. The basis of this article is the publicly available information on water abstraction in Bulgaria from 1992 to 2020. The data are published on the InfoStat platform as section water statistics by the National Statistical Institute. The information was downloaded, and then descriptive statistics, minima, maxima, and means, and the coefficient of variation were computed. Dynamics and tendency in water use were graphically presented. The statistical significance of the regression line was assessed by using the Mankey-Kendall test. The trend is monotonic when the p-value is less than 0.05. The structure of water abstraction and relative shares of water use by economic sectors were evaluated. Analyzing the structure of water use, the following economic branches were taken into account: agriculture, forestry and fishery, industry, and services. And results, the withdrawn freshwater volumes range between 5,076 million cubic meters in 2020 and 200.
Can you hear me?
Yes.
Can you hear me?
Yes, I hear you.
Yeah, because we only can hear you, but we cannot see the presentation moving. Could you repeat the last two paragraphs which you mentioned with the presentation moving?
Okay.
Yeah, now it's better. Thank you.
Analyzing the structure of water use, the following economic branches were taken into account: agriculture, forestry and fishery, industry and services. The window freshwater volumes is decreasing, and the trend is statistically significant during the reporting period. There are more dynamic changes when we track water use by economic sectors due to the land reform and changes in ownership. The abstracted freshwater volumes intended for irrigation quickly decreased from 3,702 million cubic meter to 578 million cubic meter. The negative trend is statistically significant. The withdrawn water volumes for industry continuously shrunk during the last quarter of a century, being highest in 1998 and lowest in 2020. The decreasing trend is also statistically significant, as seen in figure 3. The withdrawn freshwater volumes for services declined from 71.01 million cubic meter to 9.54 cubic meter. However, the slope of the regression line is not statistically significant. The sector structure of water consumption follows the total water abstraction with some changes during the investigated period. The industrial branch keeps its leading position, increasing its portion from 55% in 1990 to 88% in 1995, maintaining values around 80% in the coming decades. The relative share of the agriculture, forestry, and fishery sector declines from 43% to 11% in 1990 and 1995, respectively, with minor changes in subsequent years. The dynamics in the services sector, whose relative share initially decreases and after then increases, reach a maximum value of 0.76% in 1990 and the maximum one of 0.20% in 2005 remain unclear. And in conclusion, the freshwater abstract in Bulgaria strongly depends on human needs and industrial development, and it reflects the negative demographic and socio-economic processes in the country for the last 3 decades. There is a statistically significant negative trend regarding freshwater use, both total and by economic branches. In the period of 1990 to 2020, the largest relative share belongs to industry, followed by agriculture and services. The results indicate a steady decline in total water usage with restructures by economic sectors. And based on the analysis, it can be concluded that the human pressure on water resources at the national level is gradually decreasing. Thank you for your attention.
Colin, again, so I'm going to continue with my kind tasking because when you presented your briefing, we couldn't follow the presentation and only one slide which was frozen. We could hardly hear you, but anyway, thanks to the opportunity which I had to go through your article, which is very interesting and expanded my views on the water resources in Bulgaria. I have one question. According to your results in scientific research, we got figures that showed the water resources are declining. I mean, the consumption of water is declining within the years. Is that true?
Yes, that is true.
Yes. So what is the reasons nowadays to have less water consumption in industry compared to the times 10 or 20 years ago? And what are the options nowadays? Thank you.
Yes, thank you for your question. The reason for the decreasing trend in water usage in Bulgaria in the last 3 decades are related to demographic and socio-economic crisis in the country and the declining population in Bulgaria.
Okay, the reason is decrease of economy. It's not new technology, isn't it?
Yes.
Okay, thanks. Are there any questions? If no question, thank you for your presentation, and we switch to next presenter. We return to Milena Mitova. I presented her at the beginning. Thus, Milena, you can switch on. Milena, do you hear me? Milena Mitova, you can start your presentation. Maybe there is some problem with her. We don't hear you.
She's not here.
Oh. because they can be off. There is a problem with the connection with Milena. That's what to do. We finish maybe?
Shall we have 5 minutes break or? Okay. 5 minutes break.
תשובתה למה? Okay, let's continue. Milena, now it's you.
Yes, hello everyone. I'm so sorry. I have a problem. Do you hear me?
Yes, we hear you. You can start
Yes,
your presentation.
Okay, I'm so sorry, really.
What you prefer? You will share your presentation or we to share your presentation?
Yes, can you see the presentation
No,
at the moment?
we see nothing.
No? Okay.
Okay, we will do this. Only after starting, tell us when to move to change the slides to the next one.
Yes, okay.
Okay, now you see your presentation.
On the moment? Okay, okay, thank you very much. Thank you. I'm so sorry. Again, I will give you presentation on a topic, SWOT model calibration, validation, and parameter sensitivity analysis using SWOT code SFI2 for watershed of the Rusinski River, Bulgaria. The SWOT model was applied to the watershed of Rusinski River, North Bulgaria. The model was fed with data for the period from 2007 to 2021. Calibration, validation, and sensitivity analysis were performed using SWOT Cup 2090, SFI2. The territory of Bulgaria was included in the investigation of modeling the hydrology and water quality of the European continent at a sub-basin scale using SWOT model. Another reason to choose this research object is the manifestation affected by soil erosion. The Rusinski River is a tributary of the Danube River. The watershed is located in the Rus region of northern Bulgaria. The SWOT model uses GIS tools to process the input spatial data. On this slide, you can see the input GIS data.
Milena, excuse me.
These
okay.
are, yes?
Tell us when to move to the next slide.
Next to the move? No? Can you see?
Now we see the slide. Just the moment to move to the next. Okay, continue.
Okay. Okay. This is digital elevation model, land use, and soil map. The data were divided into two periods from 2007 to 2040 for calibration and from 2050 to 2021 for validation. The soil data includes 73 soil profiles. They described the dominant soil units, the prevailing soils for the watershed are Chernozems. The annual sums of precipitation were not statistically different and P less than 0.05 and were in average 536 and 507 millimeters, correspondingly for the calibration and validation periods. The monthly sums of precipitation were statistically different, P less than 0.05, only for June. SFI2 was used to calibrate and validate the hydrologic setup of the model through its interface with SWOT Cup. A sensitivity analysis was conducted using the SFI2 algorithm to categorize main parameters that more affect on stream flow. We used average monthly river discharge data for the period from 2007 to 2021 measured at the hydrological station near the village of Burjicen, Ruse region of the National Institute of Meteorology and Hydrology. For parameters, 11 model parameters were subjected to the sensitivity analysis, and used for calibration and validation parameters was careful adjustment based with sufficient minimum and maximum output values. On this slide, you can see these 11 parameters. Multiple simulation iterations were executed with a minimum of 500 simulations in each run. As recommended in the climatic characteristics of periods for calibration and validation have to be similar. The P factor and R factor sorry. Do you hear my screen? Do you see my screen?
Okay, which slide you put? Now we see the table.
Which slide?
To move.
Okay, this slide. Okay. The P factor and R factor after calibration were 0.69 and 1.35 respectively. Although the R factor showed acceptable results, the P factor still fell short of the standard value, namely acceptable P factor or more than 0.7. Nonetheless, performance in this result proved to have satisfactory accuracy. For validation, the best result after the last calibration were used for setting 50 simulations. The P factor and R factor during validation were 0.62 and 0.97 respectively. The uncertainties of the predicted discharge values were compared with the observed data for the validation period. It is not possible to obtain very high model accuracy in case on so many uncertain factors affecting the watershed hydrology. In our case, study the factors which may affect the model performance are the use of only one meteorological station with daily weather data, one point with monitoring of the river discharge, and not including the whole territory of the watershed with no tributaries of the Rusenskilon River. For conclusion, we can say that the model SWOT curve provides satisfactory calibration and validation results regarding stream flow of Rusenskilon, and the calibrated SWOT model can be used for further assessing the hydrological process in these river catchments. Thank you for your attention. Thank you.
Thank you for your presentation. Are there any questions? And I will ask a question because maybe there is some problem with the slides. I don't understand very well. If what is the result of sensitivity analysis? If your model is sensitive of the parameters or not so sensitive, because it's important.
Yes, we have 5 sensitivity parameters which we again calibrated and calibration and validation. We have 5 sensitivity analyses, and for multiple calibration and validation, they have value which we can use in the next step in the program.
Yes, thank you for the answer. Are there any other questions? If no question, are there? No. Okay. If no other questions, let's thank again for the nice presentation.
Okay. Thank you for the question. Thank you.
And it's the end of.
Online panel today. So we will continue tomorrow at 9 o'clock sharp.
He was muted. You should have muted.
I was muted.
Yes.
Fine. I said that I thank you everybody for your dedication for this online session today. Tomorrow we will start at 9 o'clock with high performance computing model and simulation GIS for environmental monitoring and artificial intelligence. Thank you very much and see you tomorrow.